Problem solved.
Good morning, everyone.
Good morning.
Good
It's very
morning.
nice to see you today. We have together with us Vladi Stevanovic. Yes. She is a director of community at Multiplayer, and she is going to talk about engineering real-time collaboration. Have a go.
Okay. Uh, yeah. Good morning, everyone. I'm very pleased to kick off this track of the Athens Cityjs conference. My name is Vladi, and my agenda for today is twofold. I first want to make a case for the fact that the ability to collaborate in real time is no longer just a cool feature, but it is a fundamental user expectation. And my second agenda item is to show you how you can add real-time collaboration to your apps, and it can be quite straightforward. And you can use an open source solution as well. Yeah? Okay. So, yeah, it does work. Before we continue, a little bit about myself. As you may have seen, I like to talk a lot with my hands, and I blame that on growing up in Italy. And I hope that you'll be forgiving about all of the hands waving, and it's not going to be too distracting. That said, my background is in community building and customer success in the tech space. I was fortunate to work for other dev tool companies like Prisma and MongoDB before joining Multiplayer as the director of community. And indeed, Multiplayer is a dev tool company. I hope that I'm not disappointing too many of you who thought it was an MMORPG, massively multiplayer online role-playing game. It's also not a software to implement real-time collaboration within your apps. Indeed, multiplayer is used by teams who are working on system design or architecture documentation. And so you would imagine being able to visualize your entire system architecture from the high-level system design right down to all of the individual components, APIs, dependencies, and all of that in real time and automatically without having to draw diagrams or update them manually. Also, you can centralize all of your system information in a single secure place, and you can collaborate with all of your team on system design anytime, anywhere, async or in real time. And indeed, I want to spend a little bit more time talking about the fact that why real-time collaboration was so important to us, and why I think it's now a must-have feature for modern applications. So I want to spend a little bit of time on this slide here. This is a graph showing the So this facilitated the integration into our application without
Yeah, did not realize this was also not a great idea. Um,
the directory service cluster to make decisions about where to person editing that same component, and those changes would be merged seamlessly into the same final state for both of them. This is how we implemented live cursors, which is also similar logic that we would use for the user in applications, and fairly similar also for typing indicators. But I don't think I have an example of that. I do have
those as well. So just a very quick recap. Everything yourself. It's open source and it worked really well for us. If you don't want to use YJS, there are also many SaaS solutions that you can check out. I can think of Lightblocks, Ably, CollabKit. There are many out there as well. The second second advice that I can give you is to embrace collaboration from the start if you can. Adding real-time collaboration features as an afterthought or only to one part of our application is just a little bit harder. And that's not
and I really enjoy building communities and talking about web development stuff. I'm also co-organizer of Cityjs Nigeria, or organizer of Cityjs Nigeria. And this is not my first rodeo. I've been doing conference talks for a while. All right, going into my talk, I want to quickly talk about a very short personal story, and this would lead into the idea of the talk. I am based in Amsterdam, where getting an apartment is a hassle, right? For you to find an apartment in Amsterdam, it could take you about three months if you're lucky. And 2 years ago, at the time, I was living in a smaller city and I wanted to move to Amsterdam. So I had a specific apartment in mind that I wanted to live in. This apartment is really nice. And how it works is basically you go to the website. If there is an availability, you pay an initial fee of 100 euros and it means you've gotten the apartment. So basically what happens then, because of high demand, you only get to see if there's an apartment on Wednesday at 12 o'clock. So for 1 month, I would go to this website every Wednesday at 12 o'clock just to check if the apartment is available. And before that, I'm just thinking, this is as a developer this, but at the time I was too stressed to even think about doing it. But then I have a friend, also a developer, and he asked me, because we're both looking to get the same apartment. He asked me, Gift, this is something you can actually do with code, right? You can actually do this, like, you don't have to always visit the website at a specific time. You can write code to do the entire process. And I wish I did, but he actually went on to, do this, automate the process. Now, when I was making this talk, I thought of a very good example that I could have done that would help my life. And yeah, so basically, browser automation can help you with small tasks like this that would entirely like save you time or help you get exactly what you're looking for. So I didn't do this at the time, but while I was preparing this talk, I went back to the website, of which I no longer live in the apartment. Just so you know, I got the apartment 1 month later, but I no longer live there. So to automate this specific task, what I need to do is use the Workers Browser Rendering API, which under the hood, it's using Puppeteer. How many of you are familiar with Puppeteer? Okay, a few of you, okay. I'll talk briefly about that and how we're using it within Cloudflare Workers. But basically what I did is I wrote a script to use Puppeteer to navigate to this specific website. And on the website, like I mentioned, if there is an availability, you would know, because on the buttons that you see, one says get notified, it means obviously it's not available. And the ones that says availability 3 means that specific apartment, there's 3 available. So what I did is I wrote code to essentially navigate to the website, check if there is a specific apartment available, and then send me an email, right? This essentially would help reduce the time it took for me to always set an alarm to go check the website every day at a specific time. Another interesting thing you could do to extend this example is, add a cron trigger. So you don't have to always, go and run the specific code. You can maybe run it every Wednesday. It just depends on the current situation. So yeah, this is like a real life example of how you can actually use browser automation in real life, right? But let me quickly talk about Cloudflare Workers, which is the underlying technology that I used in building the demo I just showed you. How many of you are familiar with Workers, Cloudflare Workers? Okay, that's good. So Cloudflare Workers is essentially a service that provides you with an environment where you can run or augment existing code. So think of it as running JavaScript functions on the edge where you're not, managing any servers, you're not provisioning any servers. You can just, ship code and, have your code or application running without thinking of setting up anything. This is an example Cloudflare Workers script. This is written in JavaScript, but you can currently write workers in JavaScript, TypeScript, Python, Rust, and a few other languages, right? So what I have here is a script that essentially returns an object to my terminal, where I entered basic data about the conference in the conference data object, and then I'm returning that as a response back to the browser. This is a bare bones example of what you can do within a worker script, where you can do things like returning a response from an API, if you will, intercepting requests, and so much more. Okay, that brings me to the browser rendering API, which is essentially the meat of this talk. So within the Cloudflare developer platform, we have this product called Browser Rendering API. Essentially, what it allows you to do is to programmatically control and interact with headless browser instance, and also create automation flows for your applications. And like I mentioned, this is built using Puppeteer. So we currently have a lot of need for this at the time before this was built within the company, where developers needed to somehow run automation scripts. But the thing with Cloudflare Workers is it uses its own runtime. It doesn't use Node.js runtime, meaning that you might not be able to use Puppeteer directly in Cloudflare Workers. So what we did is make a fork of Puppeteer. So we made a fork of Puppeteer to be able to allow you developers use it directly within your Cloudflare worker. So what we did is, oh, by the way, this came from like a need within the company, where the team that works on Cloudflare Radar, which is a different product entirely, needed to do some automation scripts where they would like to go to a specific website, take a screenshot, and use the screenshot for collecting data. So at Cloudflare, we do something called where we're using a lot of our products internally, even before we ship it out to the public. So this is one of the products that uses Cloudflare Workers browser rendering API within it. And essentially what it does is, if you go to the Cloudflare Radar URL scanner, you can use this to get metrics from a specific application or website or URL. So what happens is you enter a URL under the hood. What happens is the Puppeteer instance navigates to the specific URL, takes a screenshot of the page, and then sends it back to this service where you can take things like the amount of time, like the website ran, and a few other metrics if you would like to collect that as well. So how does this entire thing works? Like I've mentioned, that Workers browser rendering API is something you can use within Cloudflare Workers, and it's a fork of Puppeteer. But how does it work? So the rendering API combines the power of something we have internally called browser isolation and Puppeteer. So a remote browser isolation essentially is something that allows a user to interact with a web browser that is in a remote environment, right? And then what we are doing is we've wrapped the Puppeteer library so that it works directly inside your Workers project. So all you need to do when you're starting up a project that you need to use the rendering API within it is to install the Cloudflare Puppeteer library. And I would show you how to do that in a demo shortly. But another thing that we also added to ensure that you have the Workers browser rendering API working within your Workers script is to add a binding. So essentially what a binding is in the Cloudflare Workers Fair is a way for you to connect to other services. Like, for example, if you want to work with the browser rendering API, you need to add a browser binding within your Wrangler configuration file. If you're working with like KV or D1 or any of the other products, you also need to add a binding. So that's how you connect a Worker script to another service. And here I have another example. So showing you a Worker script that is creating an instance with the Cloudflare Puppeteer library. So what I have here is essentially I'm launching a browser, and then I'm opening up a blank page. I can go further to navigate to a specific URL. I can do things like take a screenshot or create a PDF page, and so much more. Just so that we ensure that we keep all the current features within the actual Puppeteer library compatible with the Workers Browser Rendering API. We've made our version open source, and we ensure that we make all the features compatible with the actual fork that we've, actual repo that we've forked, right? And right now, as at the time that I'm giving this talk, browser rendering is GA, meaning that you can go and use it right now if you have a need for a project that you need to do automation for. This is something you can try right now within Cloudflare Workers. So we've also shipped recently additional features. So initially, one thing that when it was in closed beta, one thing that people would complain about is the ability to reuse their browser sessions. So for example, if you need to perform a specific task where you need to take a screenshot of a page in several different resolutions, maybe mobile or desktop or whatever other resolutions they are, you might need to run the code over and over, because every time you create a new Puppeteer browser instance, you have to close it, right? So it's not possible for you to perform multiple tasks within that specific instance. So now it's possible using something called browser sessions, which I'll show you an example. We've also added analytics and logs, where within the dashboard, you can go and see how many browsers you've spinned up in the last couple of weeks, because you can see the period there, specific time that it started and the end time as well. And yeah, so those are two additional features that shipped with browser rendering API. With everything I've shared, what are the use cases where you can actually use this? I have shared one where I said I wanted to, check an apartment availability, and what I would do is go and take a screenshot. So there are other things you could do with screenshot. If you need to, for example, compare a specific website over a specific period, you can also use this service for that. Another thing you could do is to generate PDF from a web page. If you have a use case where you need to programmatically create a PDF from a web page, you can also use this for that. Also for testing your web application, for gathering page load performance metrics. And if you would like to crawl a web page for information retrieval, this is also a very good use case for the browser rendering API. So I would like to show you a few examples of some of those use cases that I have mentioned. Let's just hope that the demo gods have with me today. Okay, the first example I want to show you is how can you actually take a screenshot from a specific URL, and I want to also save that screenshot to Cloudflare R2. So Cloudflare R2 is an object storage where you can save things like images and other assets. All right, so I already have the code written out, and as you can see, what I've done is first I installed the Cloudflare Puppeteer library here, and I have a few other things that I've installed just to ensure the image that I'm generating has like sanitized file names and a good ID. And then I have the interface, the environment variables that because I'm using TypeScript for this, I have to define that as well. But the meat of the application is here, right? On line 19, where the first thing I'm doing is using the puppeteer.launch and passing in the binding that I've created within my Wrangler configuration file. And this is essentially what is going to launch a new browser. And what I've done here is I want to pass in a URL to, like a URL params to this application when I run it. And I want that to actually take a screenshot. So the screenshot taking, I also want to save that to an R2 storage, which is what I am doing here. Yes. Where is it now? Yes, here. So this is where I'm uploading the image that was taken from the screenshots to Cloudflare R2. And Let's try to run this and see if it works. So to run this, I'll use the command wrangler run dev, npm run dev. Okay. So based on what I've set, I can pass in a URL to the endpoints there, and I think it's something like this. So let me use Cityjs. I think it's org or com. Okay, yeah. It's going to take a bit, but this will take a screenshot of the Cityjs front page, the landing page, and then store that to R2, and then I'm returning the image that was stored. Oh, okay. Okay, interesting. So you can always change this within the code. If you don't want to take an entire screenshot of the whole page, you can, somewhere here, I think, you can pass in a different params that will just take a specific screenshot, maybe just the first page so it's a bit visible. But yeah, this is an example of how you can take a screenshot. The same applies if you want to make a PDF, right? The only thing I'll change here, I'm just going to quickly show you, is here, essentially changing so you can do page.screenshot, page.pdf, and a few other things from the Puppeteer API. So what I'm doing here is I navigated to this specific URL, the Acropolis of Athens, from Wikipedia, and I'm converting that specific Wikipedia page to a PDF, right? For this specific one, I then store it to an R2 bucket as well. Yeah, I think I have an example in my slide, so I don't need to run that because of time. Let me just go back to the slide. So this is the first demo where I've showed you how to take a screenshot, and then the second demo also very similar, but if you notice here, I'm changing the page.screenshot to page.pdf because I want to generate a PDF, and I can also pass in additional parameters like the type of format that I would like the PDF to be returned in. Okay, another demo I want to show you is specific to the use case that I mentioned, where what if you want to run like multiple instances of a specific task without closing the browser? Before now, you could do this using something called durable objects within your Cloudflare worker. Let me show you a quick example of that. Essentially, the current limit of running a browser instance is you can only run 2 concurrent browser per account, and I think it also stays open for 60 seconds, yeah. So if you want to do a task that would run more than 60 seconds, you could use something like durable objects to extend, to keep your instance alive for maybe another 60 seconds, depending on the specific task that you're trying to run. But this solution needs you to do something extra. It needs you to add durable objects to your application. But we've gotten a lot of feedback and people were not essentially happy with this, which is why we've made it easier using something called the reuse browser session. So within your worker script, you don't need to use durable object, but it's basically doing the same thing where it helps you, keep your browser instance running while you do extra things. So for example, maybe you want to take a screenshot, you want to check the performance metrics for the specific page, you could then do that. So the difference here is, let's see. So the difference here is you have, from the previous example I shared, you have to actually close your browser once you're done with whatever you're doing with your script. But here, you don't need to close your browser. You can disconnect maybe when you're done, but the browser is not essentially closed, so you can still run additional tasks if you want to. And all of this, you don't need to, pull in durable objects for the solution that you're trying to perform. So what I'm doing here is essentially just going to a specific URL and then returning the response that I get back to the browser. If I want to perform another task, I can still do that. And when I'm done, I don't need to close the browser. I can just disconnect. Yeah. Okay. The last demo I would like to show you is if you need to measure web performance, this is also a maybe good example of how you could do that. Of course, I know there are different tools that you could already use, like Google Lighthouse and the other ones that are available. But if you want to do something more detailed, or you want to, run your own performance metrics, you can also use the Workers Browser Rendering API. So essentially, what I have here, it's a lot of things, but I'm calculating different things for a specific URL that I navigate to. For example, I'm calculating the JavaScript and CSS coverage. I'm also checking for different metrics like the performance timing within the browser. All of that has different calculations that it entails. I am also calculating the time to first byte here, and then I collect all the metrics and return it. So for every URL that I navigate to, it will calculate all these metrics and return the results for me. This example you see there is from Hacker News. Let's see. Okay. So I have just 3 minutes. All right. I have shared how the browser rendering API allows you to automate different tasks. If you're interested in exploring more, I would recommend you check out the docs where you have a bit more information and examples for the different automation tasks you like to, try. I would also recommend you also look into Puppeteer, because if you'd find if you're already familiar with Puppeteer, you don't need to do too much because the API is the same. But if you need to do some additional things, also going to the Puppeteer documentation to see the different APIs is important as well. All right, we have published a few blog posts about this entire thing, how we built it, how you can actually use it within your application. So if you'd like to read that, I think you can also check out the Cloudflare blog. And finally, thank you so much. I hope this talk was helpful. Yeah.
We have a couple of minutes. Do you want to accept questions?
Yeah, sure.
Do you have any questions?
Are you back? Did you drink and you are ready for the next talk? We have together with us Katerina Skroubelou. She's senior software engineer at NX, and she's going to talk about elevating your monorepo, the next transformation. Give it a go.
Hi everyone, I'm Katerina Skroubelou, and indeed today we're going to talk about NX. Okay, good. I'm a senior engineer at NX, as Selena said. I'm a Google developer expert for Angular and Google Maps, a woman techmaker ambassador, a speaker and instructor, and a cat person. You can follow me on Twitter at CyberCity or go to my website cyber.c. Also, after my talks, I like to go on Twitter and see the pictures that people have taken from my talks. So, if you want, I'm not pressuring, take a nice picture and post a tweet because I will see my pictures afterwards. Also, I have two children. They're not human children, they're feline children. And as all parents of non-human children, I like to show pictures of my children. So I have put a lot of pictures of my feline children in this presentation so that you're forced to see them and see how cute they are. Okay? So before I start, who here has heard of an X? Cool. And who uses an X? Okay. So the rest of you who have heard of NX but not use it, I'm pretty sure that after this presentation, you are going to use it. Take my word for it. Is wrong. I have to point it. Okay. So what if, this first picture of my non-human children. What if you could do a fresh checkout of your workspace and have your app running in a few seconds? What if you could look forward to writing ETV tests? What if your PRs could be validated in CI instantly? How would that change how your team writes software? Would more features get done in a sprint? Would products go to market faster? NX brings all those what ifs to life, and we're going to see this today. So, what is NX? Here is a nice illustration. Here is your project. NX is the little nice pineapple on top, and the hand that is forcing the pineapple on the top of NX is npx NX init. NX is not just another build tool. It is a comprehensive framework that integrates your tools and helps teams build better together. Some key benefits are code sharing and collaboration. It manages multiple apps and libraries within a single workspace. It has efficient build and test caching. As we're going to see today, you can spend less time waiting and more time coding. and it brings powerful developer tools. You can enjoy building tools that enhance your development experience. So it enhances your developer productivity, it makes your CI faster, and maintains your code quality. You get code sharing, you get task caching, you get dev tools, and enhance the app. This is an NX graph, and we're going to talk about it as we move along. But you can see the illustration of your of the code collaboration and the code dependencies here. One part of NX are the NX plugins. The NX plugins are extensions for your workspace. Extensions that add capabilities to your project. They're optional packages that cater to very specific technologies. We offer plugins for most of the web technologies out there, like we have for Angular, for React, but also for Vue, for Nuxt, for Cypress, for Storybook, RSpec. We basically offer a plugin for most of the technologies you have heard of. These plugins offer additional features, making your development experience more efficient and enjoyable when working with these tech stacks. You can set up specific frameworks in a standardized manner, like you can set up a new application or a new library, and they have enhancements, optimizations, and extended capabilities to your project. But why should you use NX in the first place? First, actually second, but most importantly, is the NX Task Runner, which helps you scale, replay, and add speed to your project. The other is the NX plugins that provide automation, migration, help, and maintenance helps. We will start with NX plugin features. As I said, maintaining an automation means that our plugins offer generators that can help you generate code and scaffold your application, but also they help you with migration, offering automated updates. Also, they help you automate your setup. For the new people that just came in the room, welcome. I told everyone, take pictures of me and tag me on Twitter because I like to look at my pictures afterwards. Okay, moving along. Okay, so the generators, if you are using, I guess when you're starting a new application or project, most of you are using some sort of a CLI tool to scaffold your application. NX offers this type of thing. It's called the NX generators. They help you scaffold projects, they automate common developer tasks, and they ensure consistency across your workspace. You can generate a React application or an Angular application like the video shows. They provide a way to just keep a consistent scaffolding throughout your project, yes. The migrators that we offer, is this video playing? Yes. The migrators that we offer as part of each plugin, they they facilitate updates to newer versions of dependencies, frameworks, or libraries. The purpose is to maintain an updated code base and harness new features and improvements. So they make your life a lot easier when you want to move from one version to the other. And you can just use NX migrate latest, this command, and it will take care of updating your code, doing the necessary code modifications, and updating your packages. So it's super, super helpful for a team that wants to move forward and keep up to date with the latest versions that don't have any bugs, and we always should update the latest version. Now, the other super, super important and flagship thing of NX is the NX Task Runner. So the NX Task features and the benefits of the NX Task Runner and its features, which a task is this, like NX, test, project, and some options, right? So first of all is the cache, which we call the NX replay. So we intelligently determine and cache the parts of your project that are affected by changes. More than just saving time, it's about intelligence resource allocation. Caching in NX works by computing a unique hash I love this. A unique hash for each task based on its inputs, outputs, and other factors. So when a task is run, NX checks if it has already computed the same hash before. If it finds a match, it retrieves the cached result and replays it, saving time and avoiding the need to rerun the task. So for example, if we look at this video, if you, not at this video, sorry, wrong video, but we'll see it later on. So then we have the NX graph, which is a nice visualization of your workspace and your dependencies. It visualizes how apps and libraries depend on each other in your NX workspace, and it helps you understand the architecture of your project. Also, the affected, no. Okay. The NX affected command analyzes code changes and determines the affected projects and graphs. So for example, in this case, depending on your project graph, if you make a change to the footer project, because my app is dependent on footer and my app E2E, etc., are dependent on footer, these all projects are considered affected and are going to be rebuilt if they need. So it helps optimize build and test times in a monorepo setup, because it will not try to rebuild or retest the projects that are not affected. NX Cloud, on top of this, provides distributed caching and task execution, and we're going to talk more about this in a few moments. You get visual insights. For example, here we have a list of builds that were run for a specific, when a build for a specific application was triggered, which depended on all these projects. So triggering the build of one application triggered consequently the builds of 3 or 4 other projects. So on NX Cloud, we offer NX Agents, which is our distributed task execution, which when you have multiple tasks that you can run, multiple machines or CI agents are running in parallel, and your tasks are distributed across different machines. So let's see an overview of how NX makes builds fast. First of all, why make things fast in the first place? If you need that question answered, you get faster feedback loops, which means quick iteration, meaning immediate feedback, allowing teams to adapt, learn, and improve their work on the fly. Then it means reduce time to market, accelerate development process, can significantly cut down the overall time to market of your product, and of course, decrease developer frustration, right? No more waiting for builds and tests to complete. How many times have we just frustratedly looked at our screens waiting for that E2E test to finish or that build to finish? So NX makes all these run faster and makes us a bit happier, I guess. Some of the new additions that we have added to NX to make it even faster are these things here: Rust, replay agents, atomizer, deflaking, and some extras. First of all, we introduced Rust for file hashing. Rust makes NX compatible with native code solutions while maintaining the accessibility and flexibility of Node.js. It speeds up start time even without the daemon running on CI, and we offer efficiency when caching for archive file. NX Replay enables caching and reusing of task results. It's a remote cache. It speeds up CI pipelines for modified PRs using the affected command that I described before. And you can also speed up your local development process, as we're going to see in a video in a few minutes. All right. NX Agents is distribution handled on the NX Cloud infrastructure, all on a single line. It's CI that understands your code. You can easily integrate with existing providers like GitHub or GitLab. You get efficient task distribution, and eventually we're also going to offer a guess what AI solution that is going to help with trying to understand how much time each task will take on your workspace and suggest the best results for it. A very exciting feature that we added recently, which is one of my favorite things, is the atomizer. The atomizer automates C2E tasks. Actually, it splits up E2E tasks and E2E streets. So you know how you have an E2E street and you have to run it all, and the E2E street has inside it, I don't know, 6 different files. So it takes, I don't know, 20 minutes to run. What the task atomizer in NX does is that it splits up these 6 different files. Oops, and then adios. This is an alert for an excessive heat warning, I guess. Yes. This is how exciting this feature is. You understand? Okay. And so instead of you having to run the whole E3 student takes 20 minutes, NX will split it up in as many files as it is so that it runs faster and it runs in parallel. So it makes things a lot faster. And its setup is made very easy, as we're going to see. Also, you know how some tests are flaky and you run them once? Yes, this is also an exciting feature. You know how some tests are flaky and you run them once and they don't pass. And then you say, well, I'll just run it again. And then it passes? Anyone has done that? Nobody? Okay, thank you for being honest. I appreciate the honesty. So NX understands that automatically if a test is flaky, so it reruns it automatically for you so that you don't have to manually go and rerun it, which makes things a lot faster as well. And some extras, we are also supporting module federation and we added playwright support, which is, I don't know, cutting edge or whatever. So how can I add it to my workspace? So this is one of my children, as I said. He's very, very happy. Do not see his face like this. He's very, very happy wearing his Santa suit. So the way to add it to your workspace is this simple, npx and xinit. So it doesn't matter if it's a monorepo or not. It doesn't matter if whatever. You can just use this command today, and you will get all these benefits of NX into your application. And let's see an example in this video. So this, is it playing? Yes. So this is a React application, which I generated with the Vite CLI, like PMPM, create Vite, whatever, my React application. And you see it's set up without user NX or anything. And I go to this application, and I do npx and xinit. You can choose a version as well, or you can choose the latest, preferably. And it asks me if I want to install some plugins. It understands that I'm using ESLint for linting and Vite for building. So I choose these two. I tell it which scripts are cacheable, because it reads the scripts in package JSON. And build is cacheable. I say it's cacheable. I say the artifacts from the build go into this. And then it's setting up NX. Okay, let's, even though it's a video, I will wait because I don't want to mess up the, okay. Never mind, let's give it a couple of seconds. I'm scared to touch anything here. Okay, so you see it's setting up, it's making some changes to package JSON, and it's also adding an nx.json to set up NX. It's setting up NX Cloud, which we're going to see it right now. And then these are the things that changed. Some changes to package JSON and added NX JSON. If we see NX JSON, we see that it added some plugins for linting and for building. And then it added an NX Cloud token as well. And if we go to package JSON, we see that it replaced the scripts with using NX now. And if I go now here and I do NX build, instead of Vite build or whatever, it builds, right? It's using Vite and it builds my React app. Now, if I run it again, it runs instantly because it fetches the result from the cache. And it also gives me a path to NX Cloud. And if I go into NX Cloud, I can see my build here as well. Now, this may seem like a lot for just a single small application that just has one build script or whatever. But if you go and have a bigger workspace, with lots of different applications and lots of different libraries, if you add an X to it and you use all this change validation that I talked about and the affected and everything, I want to speed this up a bit. All right. You will start to see the benefits of an X, because you saw Jenkins get it on fire there if the workspace was naive and didn't have an X. Thank you. But if you add an X to it, this would be the full CI time if you didn't have an X to it. But if you have an X to it and it understands the dependencies of the project graph and it understands what things are changed, then the total CI time becomes much, much faster. Stuck a bit. I don't know what's going on with this. Okay. So when you start to use affected and then you start using the parallel task execution that I talked about, and you start doing incremental builds, then little by little, the CI time is going to be reduced a lot. And if you add NX to it as well, as we saw before, then the total CI time is very, very much minimized. So even though for one single small application with one script, it may not seem like a big change to you, if you add a big, big project, you can see 10x build performance improvements in CI. You see him here hiding because he doesn't want to believe it. And of course, if you're working in a team with different developers, you can all share the same cache thanks to NXCloud. And there's more tweets. The more tweets being that it's super easy to adopt. As you saw, just one command, npx and x init. We have integrations with Visual Studio Code and GitHub. We have the NX CLI GUI, which is the NX console, and the NX Cloud reports. And last but not least, Tasky, as I said, the AI-powered solution for your workspace and organization. And of course, improved productivity. And one very important thing that I want to stress before Lena cuts me off is that NX is an open source project. It's free to use. You can use it right now. And we are also collaborating with the rest of the open source community. So everything we build together with the rest of the open source tools. Like we reach out to the VT team, to the Vue team, to the Storybook team. And we try to build and collaborate with these teams all together to make sure that all the open source tools work and integrate together correctly. So npx and xinit right now to change your life. And this cuts life here. And thank you very much.
Thank you. Okay, let's try it out. Thank you, Manya, for the technical support. Cool. It's working. So, hello everyone. I have this one. Uh, my name is Milica. I'm a technical writer at Google on the Chrome team, and I work on many areas. One of them is identity and authentication. I've also been working on privacy and performance. So if you want to chat about any of these topics, please find me in the lounge. And also you can find my articles on web.dev and developer.chrome.com. If you want to talk online, you can find me on Twitter at vividigital, and you can also find my email on my personal website. Today, I'd like to talk to you about our future without passwords. And here's a little preview of what we will cover. We can talk about getting rid of passwords without first talking about passwords. With that out of the way, I'm going to tell you about the main topic of my day, which is actually passkeys. I'll tell you how they work, show you exactly how they work, and I'll tell you what kind of benefits they offer. We'll talk about one of their major benefits, which is security. We'll go over the state of support of passkeys today. And I'll show you anatomy of a passkey system and how you can implement it in your web app today. So let's get started. Passwords have been around for a long time, but they're a pain for the users and they're a liability for you as a developer. Strong passwords are difficult to remember, so many people don't bother creating strong passwords, or they use the same password for everything. I've done a little bit of research, and what I found is that bad habits die hard. 2/3 of people reuse their passwords, and 1/3 of them share passwords with others. Now, we really all struggle with passwords. Let's have a little show of hands. How many of you had to reset their password in the past few months? Right? And actually, we're not alone. 90% of people has to reset their passwords several times a year. In this survey, they actually found that 6% of people said they have to reset their passwords daily. So yeah, the situation is dire. Now, I know what you may be thinking. Password managers help here, right? Like, I don't know which password manager you're using. Okay, I'm joking. No, password managers really do help. They can generate a strong password, they autofill it to exactly the right domain or app, and they can synchronize your passwords across your devices. That's all great. Password manager can be a standalone app, it can be an extension, something like 1Password or Dashlane. It can also be built into your operating system or a browser. Google offers Google Password Manager. Apple offers Keychain. You know, we're a technical audience here. I'm sure a lot of us use Password Manager, but the reality in the world is not everyone relies on password managers. Okta has recently done a survey, and they found that 2/3 of people feel overwhelmed with the number of usernames and passwords they have to manage. Now, that aside, passwords are just not very secure. Passwords are one of the most common attack surfaces, and 81% of hacking-related breaches is related to passwords. Now, as a developer, if you store passwords, you are the one who's responsible for the liability of hacking breach. And hacking is only part of the issue. Passwords are also susceptible to phishing. Now, phishing attacks trick your users into revealing their sensitive information. So, you know, like when you go on your bank's website and it looks exactly like your bank's website and there's a sign-in form, but the URL looks kind of weird? A lot of people will enter their username and password on that page. Now, no matter how strong a password is, it will get stolen on a phishing website. Now, phishing scams have been on the rise, and they've increased 12 times since 2016. Okay, now, I'm guessing a lot of you may be thinking, but we have two-factor authentication, right? And that's true. Two-factor authentication does improve security. However, one this is an extra step for the users. And two-factor authentication costs you as a developer money. Now, that's why today I'm excited to tell you about the new technology that's simple and secure, and it's going to make it easier for people to sign in on the web without using passwords. It's passkeys. Now, passkeys are simple and secure way to authenticate online without using the password. A passkey is a unique cryptographic key pair that's tied to a user's account and a site or an app. Here's a little example. So on sites and apps that implement passkeys, the browser or the operating system will show users a prompt to create a passkey. Now, what user needs to do is just touch their fingerprint sensor or any other screen lock feature on their device to continue. They don't need to type anything. They don't need to remember anything. Once a passkey is created, the next time they want to log into this app, they will be shown a prompt, and all they need to do is use the screen lock feature to verify, and they're in. So this is the key feature of passkeys. The browser and operating system will make sure that each passkey can only be used for the site or the app that it was created for. So this makes passkeys phishing resistant. Unlike with passwords, no one can trick users to sign into a sketchy app or website. Now, passkeys are developed by FIDO Alliance. This is an open industry organization that works on developing technologies that reduce reliance on passwords. Many major companies are part of FIDO, like Google, Microsoft, and Apple. And FIDO has been working on this for over 10 years. So passkeys are not a proprietary technology. This is an open standard that's being specified and made to work across platforms. Another thing FIDO does is conducts its research. So recently, they published a stat that 58% of people abandon purchases due to difficulty of managing passwords. So improving the sign-in experience actually has a very tangible effect on the business. Some of the benefits that passkeys offer are higher login success rates, reduced sign-in time, increased conversion rates, and reduced costs of separate two-factor authentication solutions. Many apps and websites already implement passkeys. Some of them are PayPal, Amazon, Kayak, and many others. Amazon recently published that with passkeys, their customers find it easier to sign in compared to passwords and codes. Now, Google Accounts users agree, and 64% of them find passkeys easier to use. Kayak, on the other hand, found that average sign-in time reduced by 50% for people who use passkeys compared to people who use passwords on their sites. Now, these are only some of the examples. The list of sites and apps keeps growing every day, and you can check it out on passkeys.directory. Now, passkeys have been around for a little while, so I'd like to do a little poll. How many of you have used passkeys before? Yeah, okay, cool. That's quite a few hands, more than I had last year. But it's not everyone, right? So out of you who haven't used passkeys, how many of you have a Google account? Right, you have a Gmail. Well, all of you can try out passkeys today. So just check out this link, and it will prompt you to create a passkey for your Google account. Passkeys are supported on Google accounts since May 2023 across all major platforms. So I really encourage you to try it because it's so easy and it will make the rest of my talk make more sense to you. I'm going to show you a little video demo of how passkeys work on an actual demo app. So let's say I have a fictional bank website, let's call it TryBank, and I've signed in the old school way, username and password. However, my fictional bank is really on top of their game. They have implemented passkey support. So they're going to prompt me to ask if I'd like to create a passkey. I think better security sounds good, so I'm going to say yes. This gives me a dialog that lets me verify using my screen lock. In this case, it's my fingerprint. Once I verify, I touch the fingerprint sensor, and now a passkey is saved on my device. Now, next time I want to log into TriBank, I'm not going to use username and password. I will be prompted to sign in with the passkey. I'm going to select my passkey, confirm with my fingerprint, and that's it. I'm in. Like, that was quick. So the major benefit of passkeys is that they offer a simpler user experience for users. There's no typing required. The account selector just shows you a list of credentials you can sign in. And you can sign in just by using your screen lock. Now, this can be any screen lock method. It can be a biometric one, like a fingerprint sensor or a face scan, but it can be other screen lock method, like a PIN or a pattern. Now, let's talk about security of passkeys. This is a major advantage over passwords. I mentioned passkeys work with public key cryptography. A passkey is a private key that's saved on the device, and it has a matching public key that's saved on the server. Now, there is no secret saved on the server, and this makes passkeys less vulnerable to server breaches, unlike passwords. So even if your server gets hacked and an attacker gets a hold of a public key, they can't derive the private key from that. Another thing that people often wonder about is that your biometric data is never shared with the server. The biometric data does not leave the device. The private portion of the passkey also contains metadata. Like I said, a thing that ties this passkey to user account and to the specific website it's going to be used for. Now, this metadata is what ensures that the passkey can only be used for the specific account on the specific website. Now, once a user authenticates, confirming with the screen lock, a passkey is not sent to the server to be matched. What you're sending is just a signature that gets matched to the public key on the server. So if that's a match, the server responds with yes, and you got it. Now, if this all sounds cool, you might be wondering, where are passkeys supported? Well, the great news is they're actually supported in all major browsers. So Safari, Firefox, Chrome, and Edge all support passkeys. But it's actually even better than that. Passkeys are supported on other platforms. So on Android, iOS, and Windows. This means passkeys work on both apps and websites. And another key feature is they can be backed up and synchronized by a credential manager. Now, this might be a new term, but actually, it's kind of a broader term for a password manager. A credential manager is your digital vault that stores your credentials, so both passwords and passkeys. So when a user creates a passkey on the device, it can be backed up by a credential manager, and then it can be synchronized on your other devices as long as you're signed in to this credential manager. So on Android, that's Google Password Manager. On Android 13 and below, users can save passkeys only in Google Password Manager. Other companies have similar syncing capabilities for passkeys created on their operating system. So on Apple ecosystem, that's Apple Keychain. As long as you're signed into your Apple account, you should be able to back up and synchronize your passkeys across your Apple devices. Now, a cool thing we've been working on is that starting from Android 14, you can actually use third-party credential manager as well. So if you prefer 1Password or Dashlane, you can use it. If you still use Google Password Manager, the passkeys that are stored and backed up by Google Password Manager are encrypted on the device and securely uploaded and shared across your user accounts. So as long as you're signed into the same Google account, you can use the same passkey across your Android devices. However, this means you can't use the same passkey on other platforms like Apple, Windows, or Chrome OS devices, even if you're logged into the same browser like Chrome. But we're working on it. We're working on making passkeys from Google Password Manager sync to all these platforms by the end of 2024. For now, if you're signed into Chrome on your Android device that has a passkey and Chrome on a different device, you will get a push notification that will allow you to authenticate on the device that has a passkey and log in on the other device that doesn't. Now, again, passkeys are not a proprietary technology. They're still developing, and the ecosystem is working hard on making this cross-device synchronization as seamless as possible. In the meantime, if you want to sign in on a browser on a device that doesn't have your passkey, you can do it by scanning the QR code on a device that does. So, for example, I can use a passkey that I have on my Android phone to sign in on my friend's macOS computer. The devices need to be close, and you can use your camera to scan the QR code and authenticate on the device that has the passkey. I'm going to try to play a little video that shows this. Okay, yeah, here we go. So I have a MacBook, Safari. There's an option to sign in with the passkey. I get presented the QR code, and then on the device that has the passkey, I scan the QR code, get prompted, and then I authenticate on the device that has the passkey. Now, a one-time signature is transferred onto the Mac, and you're signed in. There's no work needed on the developer side to enable this user experience. This is built in into the browser and the operating system. Okay, so I've told you how great passkeys are, and you might be wondering, can we get rid of passwords now? Well, not yet. Passwords won't disappear overnight. Like any new beginning, the change to passkeys is going to take time. Password and passkeys will coexist for a time to come. I like to compare this to transition from cash only to card transactions. This took a while as well, but now at most places you can pay with cash or with card. Actually, in London, where I live, a lot of places accept card only. Now, the transition sometimes takes a longer time in a different place, Berlin, for example, but things do move. Last year in Berlin, I was able to pay by card in most places. I think the same thing is going to happen for passkeys. Now, another thing to consider, this is a fairly new technology, and for a time to come, there will be a lot of users with like older devices or older operating systems that do not support passkeys. So you should keep passwords for those users for the time being, but now is really the time to start introducing passkey support to offer better user experience and better security to users who have the capability to use. Now, let's take a look at the anatomy of a passkey system and how you can actually implement this in a web app. There are a few key terms when we talk about passkeys. One of them is a relying party. Now, a relying party is actually just a term for your website that's going to let users authenticate with a passkey. Now, this site's role is, one, create a passkey, then authenticate users with a passkey. So it has to operate a client, but it also has to operate a server and a backend where it's going to store a database of users and keep the public keys to get matched for this authentication. Now, to create the passkey, you also need a device, an authenticator. This could be your phone or another device like a tablet or a laptop. So a physical device that creates the passkey and that has a screen lock functionality that you will use to authenticate with them. And finally, a really important piece, a credential manager. So this is a software on the user's device. It can store and synchronize passkeys. Now, let's look at the system of a web app. So there are 4 components that are necessary to make a passkey system work. So first, you need a browser which can run JavaScript. Then you need the authenticator, which can create a passkey and which can authenticate users with the screen lock. you need the backend, which holds your user database and the public keys. And then you also need a front end, which is going to communicate between the browser and the backend. Now, let's look exactly how you integrate passkeys into your web app. So because this is the web, we actually use the standard API called Web Authentication API or WebAuthn. This is just vanilla JavaScript. Let's say you have a user who already has an account on your app. They have signed in, have a username and password. You want to prompt them to create a passkey. This is the function that you would call. So it's called navigator.credentials.create. This function returns a promise. See, there's like a lot of space here. We need to give it some parameters. So the first key thing is RP, stands for Relying Party ID. So this is the domain of the site that you want to associate this passkey with. Once again, this is what prevents phishing. This passkey can only be used on this site. Next, we need some user information. This will be used to identify the user in your app and also to present dialogue to the user that identifies their account. So user ID, this is a unique identifier for your database. So it shouldn't be any personally identifiable information. It's really like best to have a unique string. This is an array buffer, so any 16-byte value that's generated per account will work well. Now name, this is what we're used to. This is typically the username. So it can be a username or an email. And this username will be used to show the display dialog so the user knows which account they're signing up to. Now, exclude credentials. This prevents registering the same device by providing a list of already registered credential IDs. Next, setting authenticator attachment to platform means this passkey will be limited to authenticating the user through a built-in functionality like fingerprint scan on a specific device. We set this because passkeys actually have an option to be saved on hardware security keys as well. These are called roaming authenticators. So because you can put your security key in your laptop or your mobile device, these are called cross-platform. We're not going to get into those today. So for a web app, you set it to platform. Require resident key true means this should work without the user having to input their username. And I skipped over the challenge. This is just a random server-generated array buffer, which prevents replay attacks. So it is required, but during registration, it's not really used unless you want to do attestation, which is an advanced topic that we're not going to cover today. Now, we have all the parameters. A passkey will be created after the user consents using the screen lock feature on their device. When this happens, the promise will be resolved and a public key credential will be returned to the front end. Now, front end sends this public key along with the credential ID to the backend to be saved and associated with this user to be used for future authentications. Now we have created a passkey. Let's see how can the user sign in with a passkey. So on front end, you call navigator.credentials.get. This is another function that returns a promise, and it needs some parameters. So here, you request the challenge from the server, just a random generated challenge that prevents replay attacks. Then you specify the RP ID, which specifies the domain that the user is authenticated for. And then mediation conditional allows the authentication dialog to only be displayed if there is a passkey on this device. And here's how that plays out. So when the user puts their cursor in the sign-in field, an autofill dialog pops up that presents both passwords and passkeys. If they choose a passkey, then authentication dialog pops up that lets them verify with their screen lock. If they do that successfully, the promise will be resolved, and then a public key credential signature gets returned to the front end. Front end then sends this to the back end, which matches it against the database. If it matches the public key that we have in the database, we're successful and the user can go in. Now, I mentioned the autofill dialog that can present both passwords and passkeys. Here's how you enable that. I love it because it's so simple. It's just HTML. So on your input field in your sign-in form, you just add autocomplete username web authn. Now, if a user focuses on their input field, this will pop up both passwords and passkeys as part of the autofill dialog. Now, this will help users transition seamlessly between passwords and passkeys because the browser automatically offers them both options. So for step-by-step instructions, you can check out the workshop that's linked on the slides. You should take a picture and try it out. Now, if you don't want to go step-by-step and start from scratch, actually, there's a bunch of libraries that you can use to help you get started. So you can find them on a GitHub repo, Awesome Web Authn. There's a bunch of libraries that help you start if you're using TypeScript, Ruby, Rust, or other languages. Now, I didn't really have time to get into the server side, but there are also libraries available for different server-side implementations like Java and PHP. Okay, so let's recap what have you learned today. Passkeys are a replacement for passwords. You don't need to type in anything. The device will offer you an account selector and passkeys to sign in with. Now, you authenticate using your screen lock, and it could be a fingerprint, facial recognition, PIN, or a pattern. And a cool feature is passkeys can be synchronized by credential managers and accessed across your devices. Now, they're much more secure than passwords because they're based on public key cryptography and they're phishing resistant. So a passkey can only be used on the service that it's registered for. And best of all, they're supported on all major browsers and operating systems. So to learn more about passkeys, you can check out the documentation on this link on developer.google.com. We're well on the way to a passwordless future. By implementing passkeys today, you get better security, a better user experience, and happier users. Thank you for your attention.
Thank you, Melissa. We don't have time for questions because I know you're hungry.
You could see that coming. Let me explain with a graph. On one axis, we have project complexity, basically how big is our project. And on the other, we have pain. Pain is an indicator of code quality, and it is also measured in WTS per minute. The correlation between the two, it's not linear. The more code you add, the more dependencies you have between the code, which increases pain exponentially. There is a section on the left that everyone is happy. The code base is small. You can easily understand what's going on. You can easily refactor things around if needed. You can take some terrible decisions, and it will not really matter in this case. Unfortunately, we evaluate front-end frameworks and proof of concepts with projects in this category, which doesn't expose real-life problems. It's usually a to-do application, which it doesn't really solve the problems. On the other side, we have really large code bases, and the only known solution to this category are micro-frontends. Let's see some hands who is familiar and working with micro-frontends. Okay, many people. And who is happy with micro-frontends? 3 people. I will love your insights. You should make a talk next year. You should talk to Aris. Because my experience more or less aligned with the rest of the room. When you have a really big code base, you have a lot of issues. And then you introduce micro-frontends, and then you need to solve again routing, state management, performance, code duplication between micro-frontends on top of your existing issues. I'm not against them. They're adding more problems than they solve if you add them prematurely. That's my point. I will not talk about micro-frontends today. There is a talk at 5 if you are interested about them. And I will not talk about tiny code bases as well. I'm going to talk about what's in between. And probably most of us are working on this kind of projects every day. First, let's see what the big front-end frameworks think about this matter. React doesn't have an opinion. This is taken straight out of their docs. Basically, it says, I will do things reactive. You figure out architecture, state management, routing, and everything else, which is fine. There are more opinionated frameworks like Gatsby, Remix, Next, if you want that. React doesn't take decisions for you. The same applies for Vue, but Vue doesn't acknowledge this at all in their official docs. The only speaker that had a keynote about this during the last Vue.js Amsterdam meetup conference, proposed a flat folder structure and having the component name as a prefix to group related components together. Of course, you use the tool application to demonstrate this, and you can tell that this will not work. I think even for small projects, this is a terrible idea. Even for medium, even worse. Lastly, we have Angular. Angular is more opinionated. It has modules and feature modules by default, which is one of the many things that you need to learn when starting with it. It keeps a lot of people away. But Angular is actually right. Having small independent entities inside your code base is the key to a reasonable architecture. So let me show you what works for me. Everything starts with a router. It's a core functionality in any application. It helps us map the current URL, which is the entry point, to a page component. For me, it's important to have them all in one place. You can have each module declaring its own routes. But then if you have different user roles or different access rights or dynamically declared routes, it's very hard to understand what's going on in the code base. Having them all in one place makes sense. And when this gets out of hand, it's a good indicator that we need to move micro-frontends. Then we have pages, again, all in one place. It's important, though, to be very, very lightweight. Just declare a layout, some components, and that's it, nothing more. If you find yourself declaring too many components, just group them in a new one and use that instead. Then we have layouts and components. Layouts are very important to have a consistent look and feel across the whole application and reduce a lot of boilerplate code. We have components, which is all global components, and you know that global is a bad thing in programming. So actually, this should be, you should avoid adding things here. It's not realistic having nothing here, but if you try, please do, because your application needs to be split in features, and most of your code should be inside this folder, features folder. We expect many subfolders inside here. I will return in the next slide. Let me show you first some more folders that you might are already familiar with. We have assets for our static assets, images, fonts, and styles. We have the lib for third-party configurations like Bootstrap, Tailwind, Axios, or whatever is trending this week. Then we have types. Sometimes you have some globals in your code that you need to declare them somewhere for the TypeScript compiler to stop complaining. And lastly, we have tests. Not for the spec file. I believe the spec file should be right next to the component in tests. But often you need some mocks, some helpers, and some configurations, and this is the place for them. So let me backtrack a bit. We have the features. Again, we expect multiple subfolders inside here. An example can be the profile feature. And we have, sorry, spoilers. And we have even for some folders inside it. We have API for all our fetching logic. We have the state management inside the stores folder. We have components for this specific feature, composable types as well. And we also have an index file that acts as a public interface. Everyone should, you can see what's going on just by seeing this file, and everyone should only import from this. Let me convert this to a more familiar view. I think this is simpler to understand. Again, let me repeat, we have router that maps the URL to the pages, layouts, components, features, asset, lib, test, and types. Inside features, we expect multiple subfolders, one for each feature of the app, and its feature has API, stores, components, composables, types, and an index file. If you want to take one thing away from my talk, this is a slide. I'm calling them features because modules are something different in Angular and Next, and it was causing some confusion. And one more thing to note is that each folder inside the feature is optional. You might not have fetching logic, you might not have, actually having stores and composables makes no sense because they were probably doing the same thing. The only mandatory thing is the index, which let me expand a bit on this. It's a popular pattern in the React world that I think it makes a lot of sense. It helps you detect circular dependencies when your module imports something from another module. That module also imports something from yours. You get a generic error. This doesn't solve that, but helps you detect what's going on easier. And I think the imports also look a bit cleaner this way. You can enforce it with a ESLint rule. And about pages, I told you that they need to be lightweight. This is what I'm talking about. I'm using Vue, but I hope the code is easy to understand. In Vue components, we have three sections: a script, a template, and the styles, which in this case are omitted. Everything imported inside the script will be automatically available in the template. And this template just has a layout, some components for the main content, some components from the sidebar, and that's it, nothing more. So this is the architecture that I think it works more or less. There is an optional step if you want to build a quality code base, and this is adding a design system. A design system is a collection of components, guidelines, and design patterns created from the designers and implemented by the developers. They need to work together in order to build this, which is the main benefit. I have worked in many companies that there are different departments, each one doing his own thing. And you can tell from the website that different teams designed this section. A design system solves this. The goal is that the end user that gets a feature, the feature will look more or less the same no matter which team designed or implemented it. There are many ways to implement it. There are some ready-made solutions like Bit.dev or Zero Height, or you can have a custom implementation like, again, many ways to do it. I'm going to show you a simple way. It's by adding a new folder. I'm calling it core UI. Then inside we have even more folders. We have all our design tokens inside the token folder implemented in CSS or SAS variables. We have helpers for all our mixins and code to do theming, etc. We have styles for all global styles. An example will be reset.css. Then we have components. This is where our component library will go. And we have three options here. We can have a third-party library like Bootstrap, Beautify, or Element UI, or whatever, which sounds easy and works until it doesn't, in my experience. I can spend a lot of time removing third-party UI libraries for code bases and most often for memory leaks. Another solution is to have a custom implementation, which sounds hard, but it's actually even harder if you wanted to do it properly. That is, you need to do accessibility, interaction between components, different screen sizes, etc. And there is also a third option, which is a hybrid approach based on headless component library. And headless component library is a library that with functionality but without styles. You need to write the styles according to your branding, and I think nowadays it makes the most sense. The most popular and my favorite is Radix UI if you want to check it out. And last thing, it's the docs. Again, a design system is more than a component library. You need guidelines to do your branding, interactions, accessibility, and everything else. And then you use a tool like Gitbook or Storybook in order to have this available for everyone. I think that was it. That was a theory list. Sometimes in practice, theory doesn't work. That's why I had the code base, but my laptop didn't behave today, so I will not. But I will plug in the code base if you want to see it. This is my handle. I'm using it almost everywhere. I've seen that many people posted the many speakers showing their cuts, but I didn't, and I will post it on Twitter afterwards. So if you have any questions or feedback, let me know. Thank you.
We have time for questions, but because the other microphone is down there, can you help and give the microphone hand by hand? Great. So you can say here, and I will. Yes. Okay. So you will use this. So do you have any questions? No. So
Hi. What about the state? Where you save data for the state? Like,
I have a folder called stores.
okay.
Where
Okay.
the state must go. But you can also use composables. I think in React there are hooks, which are you can either choose one, but either one will work.
it's done.
Well, I've got one question. You mentioned that there is a folder called features.
Yes.
And I'm interested because sometimes some features overlap. Like we've got simplifying it, a dashboard that combines different features, or like another feature that uses some subset of the other feature, let's say table with other features included. And how you handle that, like how you cross those borders among those feature context different ones.
Yeah. Each feature it's more or less independent, but of course you will have some overlap for sure. You can import something, someone should own something and export it for everyone else to use it. This is how you do it. Basically, the profile, let's say, owns the card of the user, and the sidebar imports and use that instead. But someone should own it, and everyone else should consume it.
Hello. One question from me. How do you decide how to split
He's going to talk about data fetching and list Next.js, React, query, and their BFF.
Thank you very much. So we're going to continue the theme of architecture in front end, and that's going to be the afternoon pretty much. Can everyone hear me? Yes? No? This is not turned on. Hello? Okay, cool. So we are going to be talking about data fetching unleashed, solving the problem of resilient and performant data fetching in an unideal world. So we're going to be talking about Next.js, React Query, and the BFF pattern. So that doesn't necessarily just stand for best friends forever. So a little bit about myself. As I said, I'm an engineering manager at Navron, also the front-end subject matter expert, helping with the technical strategy over there for designing a API and portal for financial solutions and being able to do global payments and collections. I'm also from Switzerland, the land of cheese, chocolates, and watches, and also from Pakistan. My passions are web performance and engineering leadership, and I'm also a frequent open source contributor, particularly to a project called Raycast. You should definitely check it out. So the first thing I want to do is set the stage. There is no one-size-fits-all solution. The favorite answer to any question for a programmer is it depends. So this pattern, these architectural things that I'm going to be showing you in just a minute, that's not just going to be for every single project. So we can't just copy and paste it all across the board, but this is going to work for a particular type of situation. It's mainly going to be a story about a problem I tried to solve around about a year ago, and that solution is still holding and scaling till today. This is also not a tutorial. We're not going to be building an app from scratch, but we've got 3 demos, a little bit of code, and some architectural flow diagrams to look through. And I've got just about 20 minutes to do that before Lena kicks me off. So we won't cover everything. There are lots of libraries, a lot of different patterns that we're going to do. This is just a starting point, so we're going to just touch the surface. It's going to be the tip of the iceberg. And then finally, I want to just put a little bit of a note around pragmatism and around premature optimization. You can have all the amazing patterns, all the resilience patterns in your application. You can make the most performant components, use the best state management libraries, but if you've only got one user, there's not much point in doing that. So you have to build something that's valid for the state of your application, the growth of your application, the scaling that your application is going to go through over time. So it's good to understand all these concepts. It's not good to put all these concepts from the get-go in your applications. So think about if you're pre-optimizing or you're doing it at the right time, and it's a data-driven approach. So what's the problem statement? What are we trying to solve today? What challenges do developers face in creating a seamless user experience due to complex data fetching and management? Something I would think almost everyone has been solving for since they've started programming. Moving forward, why bother do this? Why is it interesting? Milliseconds are crucial for user satisfaction in the digital space. Quick loading times are directly related to user happiness. Pages that load in 0 to 2 seconds, which is also known as the golden window, have the highest conversion rates. And there's also some research that shows a 32% increase in likelihood at bounce rates when page loads increase from 1 to 3 seconds. Moving forward, what are the technologies that we're going to be looking at today? If React is the library, then Next.js is the framework, and that's what we're going to be using today. Next.js has got a lot of cool features. I'm sure you can read those up in your own time, but a quick highlight of those are going to be server-side rendering, static-side generation, file-based routing, and API routes. Then we're also going to be marrying that with React Query, which is a powerful asynchronous state management library. React Query actually is often confused with a data fetching library. React Query, in fact, actually is a state management library that helps you manage global state. It just so happens to be really good at helping you fetch that data to and manage it and cache it. So what does React Query give us? Automatic caching and background updates. You can fetch, cache data, update it for all your React components. Optimistic updates. So when you want to send off a request but already change the UI before the response comes back, React Query is really good at integrating that. Pagination and infinite loading. When you've got a lot of data to show, you don't want to show a list of 1,000 things. You may paginate those. That's going to optimize your pages. And then prefetching data before it's needed on the server or via various methods. React Query really helps with that too, to make sure you've got a snappy user experience. And finally, cache invalidation is a notoriously difficult problem, and React Query helps with built-in cache invalidation. So Bare bones data fetching. The problem that we're trying to solve, the problem that I tried to solve around a year ago, is our front-end team needs to design a dashboard chart that displays the distribution of birthdays for the top 5,000 users in our system. This is just a variation of the problem. We weren't actually looking at people's birthdays, but this was actually for payments and transactions. The data source is available via an API, which returns a list of users with all their data. The limitation, the backend team is unable to provide a new endpoint or a data warehouse that returns the required data format, and there's a limit of 1,000 users that I can fetch on each request. Now, in software development, we talk a lot about sometimes ideal scenarios when we have everything ready for us, all the resources possible, but that's not how the real world works. If you've been in any software team, there are always delays, there are capacity issues, there are just things that you need to be empowered as a front-end developer to solve without relying on external teams. This is especially if, for example, your in-house built API is an external product and you're selling that as an external product and you can't necessarily add new endpoints to suit your front end because that's going to have to go through breaking changes, potentially deprecation policies and so on and so forth. So you've got to start getting creative. How do you make an optimal solution in an unideal situation? So demo one, we're going to start looking at an architectural model. Then we're going to look at the demo app. And then we'll see what we're implementing from the start and how we're going to evolve that over the next couple of demos to an ideal solution. So this is what our application looks like. It's just a simple chart. It's got a distribution of how many people's birthdays are there per month. And we've got 5,000 individuals to count for. In our basic version of our application, how are we designing this? We've got a UI. Because there's a limit of 1,000 users of data that I can request for in every single API call, I've got to make 5 API calls for that 5,000 pieces of data that I need. Then, with a good user experience comes a loading state. Something's happening in the background. We're fetching information. We've got 5 promises that need to be resolved. We have a potential happy path. So if everything's all good, we'll take the data, we'll map it to the structure we need to send to our props. Then we'll set it in state. We'll render the UI. However, there's a problem there. Depending on the state management solution you have a risk that every time you make a state change, your component's going to re-render, it's going to re-trigger the fetch. And if you're re-triggering a fetch of 5 parallel requests multiple times, you risk a 429 response from that API because you're overloading it, you're stressing it. Especially if you're paying per request, that costs money, and especially if you have an API with rate limiting. So if there's a sad path, it doesn't respond for some reason, we do what any normal system might do is you keep persisting the loading state. You're going to keep on showing it. Nothing's resolved so far. And you're going to attempt to retry. It didn't work time 1, so I'm going to do it all over again. And that whole path starts. So let's say we're doing this with custom logic. The problem with that is it needs testing. It needs maintenance. It's subject to bugs. There's state management complexities. If I don't handle my state management correctly and I re-render components at the wrong time, the refetches trigger, start overloading and stressing my server. The data mapping effort is on the client side. So there's potential needs for memoization and optimization there. There's a lot of effort in calculating, manipulating data. And there's no optimization at the payload level. Remember, we're using an endpoint that isn't necessarily designed for our front end, so it may have redundant data in it. So if we look at the demo, I'm going to refresh this page. And you're going to see 5 requests triggered. This is painfully slow to look at. And it's going to be returning a lot of information right now. If we see every single request is returning around 475 kilobytes, making around the total payload size of 2.3 megabytes. If we were using local storage as a cache solution, that would not be viable because after 2 bulk requests like this, you've almost run out of local storage usage in most browsers because it's around 4 to 10 megabytes depending on the browser you use. Then if I try to hide this UI and show it again, that state change, because it's not optimally handled, is going to re-trigger all the fetch requests. And now I have, again, data that is not necessarily stale. I don't want to refetch it, but because I've designed my state management poorly, that's just happening as a side effect. So if I dive into the code a little bit, this is a custom solution. What we're doing is we have a use fetch data function. It uses a fetch under the hood. It's going to go query an API. It's going to go get fake data, which is making 5 parallel requests under the hood. Then we're going to do some effort to map that data. The data isn't necessarily in the structure we wanted, so we're going to get the birthdays by month. We're going to map the chart data then we're going to set it in state. And the story starts all over again the second you hide it and show it again. Because again, this component that's rendering the chart is a child of the parent that controls the state. So again, you'd have to rethink your state management for this to work really well. So one more thing just to show, if I look at the data over here, every single object that's being returned has address, bio, city, company, country, things that I do not need for my front end. So I'm getting a much larger payload than is needed to display all the information that I need. So this is not an optimal solution. This is also going to add memory usage. This is also going to strain your cache a little bit more. So what do? Moving on to their best friend forever, which is the BFF pattern, otherwise known as a transformation bridge or an aggregation proxy. So this is a pattern that you can use and adapt essentially a backend that you don't have much control over for your front end's usage. So you're adapting for your platform's requirements, whether your front end's a mobile, whether your front end is a web application, whatever it may be, you can cater for the unique data requirements and formats that needs. You're decoupling concerns here. So if you have got a large team and you want to dedicate 1 or 2 individuals to work on that proxy, on that aggregation layer, they can do that and they can work on optimizing that while the rest of the team is working on the UI layer on the front end. Then you can also optimize performance there. If I take that large payload that I'm receiving, around 2.3 megabytes, and I map that on the server, and I really reduce that to the bare minimum, I'm sending only what my front end needs, which means if my backend server has a great network bandwidth, it can go fetch that information real fast. And if my mobile phone or any other device is strained on the front end, I only need to receive the minimum amount of data to make that work. So you're also optimizing on the network level for this. And you can have a streamlined API evolution. You're not messing between the front end code and the back end code. You've got a clean separation of concerns. Any errors that occur on that API handler, that proxy you create, it's going to encapsulate those. You can observe those with tools like Sentry, so on and so forth. And you're kind of saving yourself from a little bit of pain of error handling that on the front end. So what could the payload optimization look like? This is the object we're receiving, 5,000 of these. We don't need that information. Moving forward, we're going to restrict that to this amount of information. Now we're going to look and see what's changed in the architectural diagram. So model 2. If I move over here, we're starting the story all over again at the UI. We're going to make now 1 API request to a Next.js API handler. You can build those in with Next.js. That's really cool, one of the features that it has. If you're using a React application, you can just spin up a Node.js microservice. It's not something that's tied to Next.js. This is a pattern that can be used with any type of framework. That API handler is going to make 5 parallel requests. The same thing we're doing on the client side. It's going to move that effort to the server side. Happy path. We have that server data returned on the server. We're going to map it there. The exact same thing we're doing on the front end, we're doing it now on the back end. We're going to send that data to the client, set it in React state, render the UI. However, we're still subject to the same state problem, which is if I don't handle my state correctly, I click some change, it's going to start that fetch over again. We're still straining our resource. So what are the benefits we have here? The payload can be optimized. Data is pre-mapped and sent. We've got a clear separation of concerns and a single request failure rather than having to handle multiple request failures. So let's look at a little bit of a demo and see how our front end has started to improve with this. So I only have to make 1 request. Isn't that a little bit faster now? That was a lot faster than the previous one. Can we see how the size of that payload? 666 bytes versus 2.3 megabytes. I'm not sure if my math is right, but I think that's a little bit smaller than what we saw before. Now, if I have a look at what is being returned, just the data that I need for my chart, how many birthdays, what the month is, and that's exactly what I'm going to inject right into my props. However, we're subject to the same issue where if I hide and show that, we're going to start that loading process all over again and fetching the data. It's still fast, but we can do this better. So I think I'm moving straight to demo 3. So if we look at that architectural diagram, we're going to start again at the UI. And now we're using React Query. So we're not going to have any custom data fetching solution. We're going to use React Query out of the box. Now React Query tracks and controls the loading state by itself, not something that we have to do, not something that we have to maintain. Our server is still going to be making those 5 API requests. If it's happy, the data is mapped, same as before. the data is now sent to the client and cached on the client. You can now choose if you want that to be in-memory cached, or you can have it as an offline cache. It depends on the use case. Now React Query will derive the response it received. You don't have to do that yourself. It'll render the UI. And now if there's a React state change, we're going to check the cache first. If there's a cache hit, we're going to go straight back to rendering the UI. We're optimized already. If there's a cache miss, we're going to start that process all over again. And we are going to start with a loading state, 5 API requests, so on and so forth, moving forward. So what's changed here? The library controls the loading and error states. Optimized payload can be cached, and you can use multiple caching strategies for that, depending on your application. You're deriving the state directly from the response. Stale data management is there too. You decide when your data is stale. Either it's stale after 60 seconds, or it could be after 60 minutes. You decide. React Query handles that. Your state management is managed for you. You don't need to use any local state. You don't need to fetch the data, put it in a use state. React Query will handle that, and you can actually use React Query, depending on the query keys, and I'll show that in a second, in any of your children or sibling components, and it will derive the response and the state from that same cache. So it's not going to refresh the data. You don't have to pass it around. You don't have to put it in a global state store. We're going to limit refreshes with re-renders, and we can configure the resiliency. So if automatic retries don't work, and retries are really a pain to implement, what you can do is you can add delays. Retry 1 happens. I don't do it immediately. I wait 100 milliseconds. Retry 2 happens. I wait 500 milliseconds, whatever it is. Then you can also implement an exponential backoff strategy, which means that if your API, you don't want to hit it every single time with the same delay interval, you can have an exponentially increasing interval. So the first retry is in 1,000 milliseconds, second one in 2,000, then 3,000. And APIs with rate limits or timeouts or something like that, it's going to be a lot easier to recover from those states. So you can use different strategies, and those are built in. And we can do one more thing. So if we move over to model 4, we're actually not starting at the server. Or actually, before this, I'm going to show the React Query code. So if I look over here, now React Query is handling all the data fetching for us. We can check if it's still currently fetching, so it handles the loading state. We have the stale time, and we have query keys, which means that I'm telling React Query that faker and whatever quantity I'm fetching for, depending on the query parameters, is what I want to store as the key for this information. And every time I reuse this hook somewhere else, that's where it's going to derive the state from. That's how it works as a global state management. So the last thing is we're going to look at the server. So this time, to optimize it even more, we can actually balance the load and move it over to the server and pre-fetch the data. So in an ideal world, we'll make the query on the server, and the code looks like this. And you'll have get server-side props right at the bottom. And what get server-side props is going to do is it's going to create a prefetch. It's going to use the same query key. It's going to fetch the exact same data, and it's going to create a dehydrated state, send that to the client. It's going to hydrate the client on the client side, and then React Query will derive the state from there, and it won't have to fetch. But this is subject to one problem. That problem being that what if my request takes 3 seconds to resolve? The user's not going to see anything. That's also problematic. So another resilience strategy that you can implement is timeouts. So if you see over here, I've put 1,500 milliseconds. And I'm telling this function that if my server-side response does not resolve in 1.5 seconds, abandon it on the server, go direct to showing the UI, show some loading state so there's interactivity on the website, and try to recover yourself on the client side. And this way, we're making our system more resilient by setting a timeout. And so you're doing the exact same thing as before. You're optimizing the payload. You're attempting the retries the way you did. You're trying to prefetch and optimize for a better user experience on the server side. But if that doesn't work in an ideal scenario and it's still taking too long to resolve, you're doing it all on the client side again to recover from that state. So you're trying to get the best of both worlds when your network connection is optimal. And if we look at the final demo, we'll actually see that if this works really well, right now it didn't resolve fast enough because the network connection is slow. But if I increase this to 2,500, and I believe I'm running a build server. Bear with me. Then I'd put 25,000. Wouldn't make a difference in this scenario. Either way, I'm trying to have a timeout that is larger than how long it will take the request to resolve. If I load this, and it takes a little bit of time for that server to kick up, you should see that it's going to show immediately, and we're going to have no loading state. So it might take a second for that to pop up. OK, cool. So I'm going to just retry that one more time. Let the demo gods be with us. Cool, that was instant. So now it's not running on the build, it's running on the dev server, so it's a little bit slower, but there was no loading state, and it instantly was loading. You can also see that if we try this one more time, there will be no fetch request that you can see on the browser, because this actually happened on the server side, and this would be if it met the timeout requirements. So for example, this didn't, and that's why it's recovering. The final thing we'll see is that if I try to hide this and show it again, it will derive it directly from the cache, and so we're not refetching everything all over again. And thank you very much.
We don't have time for questions, but you can type Others, Ceylan. Okay, let's see. Okay, we're good. And he's going to talk about, sorry, I'm in the wrong page. Okay, WebAssembly revolution, evaluating JavaScript, React, and performance, right?
Yeah,
And
reach and performance.
other is an award-winning technical reader. So go.
Thank you very much. Hello, hello. Welcome, folks. Thank you for being here. Every great dream begins with a dreamer, and I would like to see some of the dreamers here today. Alexis says, I want my CPU-intensive tasks, like image and video processing, perform as performant as native platform libraries on my web app. Are there any Alexises here? Raise your hands, please. Hi, Alexis. And Nikki says, I want my teams with C++ and Rust expertise port their existing libraries to the web app. Any Nikkis here today? Hi, Nikkis. And Costa says, I would like to compile my code to run it on any platform with any type of CPU architecture. Are there any Costas? Hello, Costas. I feel you. And Yanni says, I run my web app on devices with limited resources and my users suffer from poor performance. Are there any Yannis? Hi, Yannis. My name is Önder Ceylan. I'm originally from Turkey, and I have been living in Netherlands for almost a decade now. I work there as a tech lead, helping clients as an independent contractor. I'm also a WebGD, and I'm the maker of open source library, PWS generator. And you can reach to me on my Twitter handle, Önder Ceylan, or on LinkedIn after the talk. And today we are going to talk about WebAssembly, an introduction to it, what and why WASM is, and some of the past dreamers. We will discover some real-life use cases. We will see where to get started, and we will also continue with the dreamers of today and see where WebAssembly brings us into the future. Don't worry about the slides. I have some links and resources there, but you will have the QR code for the links to the slides in the end. Let's start with introduction. What is WASM? WebAssembly is a low-level binary instruction format for the web that is compiled from other languages to offer maximized performance and portability. For major browsers has shipped WebAssembly 1.0 in 2017. It's been a while. The community group members of WebAssembly, they reached to the consensus about the binary format and the initial phase of the WebAssembly. And since then, WebAssembly is part of our lives, and it's standard on all these major browsers. An initial use case of WebAssembly was augmenting JavaScript to run native code in a fast, portable, and secure way, and it was focusing on 3D graphics and games running in the browser in the beginning. Why we are using WebAssembly is efficient and fast because of the binary representation. The size is smaller compared to the code that we typically ship to the browsers, and the load time is efficient. It's safe. It runs in memory-safe sandbox browser and execution environment. It has the same browser, same origin policy, and also the permissions policy applied to it. It's open and debuggable. The binary format with a pre-printed text representation helps us understand the text format of the binary code that we are building. And it's portable and flexible. We can compile it from other languages and create a single compiled binary to use in multiple platforms. We will see about the compilation differences later on. And here's the basic example of a C code with a factorial function. This function, when compiled to WASM, is creating the WASM binary format on the very right end. And the texture representation sits in the middle. It's called WebAssembly text format. It's there just for us to understand the texture representation, to debug it in the browser, and create articles around it, show a representation in a format that we can understand. Because WebAssembly is portable, I would like to show about the behavior of programming languages, especially the difference between interpreted and compiled languages. and show the benefits of building WebAssembly in a portable way. When we are using an interpreted language like Python, Java, PHP, JavaScript, or Ruby, we are running our code against an interpreter. That's a runtime we download to our computers, to our systems, and that runtime is compiled for a certain CPU architecture or certain operating system. So if you're going to run a PHP code, you're going to download the PHP runtime. If you're on macOS laptop, you're going to download it based on your CPU. If you're using the ARM CPU, you're going to download the ARM version. If it's Intel, you're going to download the Intel version. With the compiled languages, it's a bit different. There's no interpreter. You directly compile your code as an executable, but this time you create your executable per operating system and per CPU architecture. So if you're writing your code in Rust, C, Go, Kotlin, or Swift, depending on your target operating system and architecture, you must generate multiple executable binaries and ship it to your users, depending on their host environment. And WASM is different in that aspect because it creates one single output. You don't have to generate a compilation against an operating system or a CPU architecture. It's always one. And no matter if you're using C, C++, or Rust code, when you compile it, you have a single target, and that's WASM. And it creates this WASM module, and WASM module is running against a WASM runtime. So initially, WASM was focusing on the browser runtimes. So we will start with the browser use case, and we will then see what other runtimes we can run WASM modules on. Let's discover some real-life WASM use cases. This is an example from 2019. eBay engineers, they struggled a little bit with the barcode scanning functionality running on their mobile web application. The success rate of the scanner was not good enough for them. They were using a JavaScript library called barcode scanner, and they wanted to improve this. And they actually ported their native C++ based library that they are actually using with their native mobile applications. So they compiled that library into WASM module, and they also noticed there are some issues with that library. It wasn't scanning good enough in a blurry environment. So they also fall back to another open source library called Zabar. They also compiled that one into WASM and raced these three solutions against each other by running them on the workers whenever a user is trying to scan a code. By doing so, they actually reached 99% success rate with the barcode scanner in all the environments and use cases they were aiming for. This is another example of WASM use cases. There are a lot of ID scanners and face recognition applications running directly on the browser. They are particularly designed to do so because when they are run on the browser, your data is never shared with the cloud, so the data is on the device, and you don't need to download any applications. So you're on a form, you click on a link, you open a web app, and that web app, thanks to these WASM implementations, can scan your face, have OCR functionality, scan your passports, and etc. And AutoCAD Web uses mscripten to port a large code base of AutoCAD that is older than 35 years old, older than maybe some of us here. And it wouldn't be possible without mscripten. mscripten is a library that allows porting large code bases. It also provides utilities to port native codes into web apps. And this wasn't an easy journey. They tried for more than a decade. In 2010, they created a Flash version of the AutoCAD. It didn't succeed. And then they had this Ajax-based web version, a very light version of the desktop app. They couldn't build more on it. And finally, they were able to port their application by using this approach. So they used 35 years old AutoCAD Core, C++ Core code here. They ported it to WASM, and they built the canvas, the same canvas that we are using on the desktop app on the browser itself. And they built a bridge for the messaging API. They also created the UI component library. They are running on the desktop application for the canvas, like the crossover and some other signature UI of the AutoCAD. It was part of the canvas because of WebAssembly binary. And finally, they built the application UI on top of the canvas. This is a common pattern we see, especially with the graphic applications. The canvas itself is ported from the native application, the original application, and the application UI is built using web elements. In this case, it's React and TypeScript. Figma, I bet most of you know Figma. I love it. It's a browser-based interface design tool. It's based on 2D and WebGL rendering engine, and it's very good on processing very large documents. Figma is written in C++, and it was originally using Asm.js. Asm.js was the Wasm.js before Wasm, so Wasm actually succeeded Asm.js. And by compiling their source code from C++ to Wasm instead, they speed up their load times by 3. And Photoshop Web, I used Photoshop for a long time, and the idea of running a software as complex as Photoshop would have been a dream also for me as a web developer. But it's there now. Photoshop is on the web, and this was also not an easy journey. It was a collaborative effort of Google and Chrome engineers and also Adobe engineers. And it goes through a lot of web technologies. For instance, they ported C++ code to Wasm with mscripten. There's the Canvas core that we were talking about with AutoCAD. It also applies to Photoshop. They also integrated file system access API and high-performance storage of large files, P3 color space, web components, and lit elements for the application UI, like the pattern that we talked about. The application UI you're building on top of Canvas can be based on web. Then you have all the benefits of accessibility, dark modes, and all the features that web apps provide via these elements. And then service worker caching the bugs, and SIMD instructions as Wasm advanced performance primitives. Thomas Steiner has a really nice talk about it. If you want to get into details about this journey, you can watch this talk later. And WordPress Playground is a very interesting project. I was a WordPress developer for a long time. That's how I actually learned programming. And seeing WordPress running in the browser was amazing to me. Like, because I remember myself running Apache servers, MySQL, PHP versions on my machine, switching versions to test it. Right now, you can run it. If you navigate to WordPress Playgrounds, you can actually choose a target PHP version and a target WordPress version and run it directly in your browser. You can sync it to your local file system. You can test your themes, plugins, and etc. And this wasn't easy as well. They had to first compile an interpreted language PHP, because it's also C-based. So the interpreter of the PHP was created as a Wasm module. With mscript, and they created PHP versions as Wasm modules and created this PHP runtime environment in the browser. So if you want to run PHP on the browser, you can also directly use this approach. So now we know some powerful examples, starting from small components to large applications. Let's see how we can actually implement our own solutions using Wasm. Before implementing our own code, it's good to know there are more than 1,500 NPM libraries with Wasm, so you can check out them. There's also a new registry called Wasmer. If you go to Wasmer packages, there's a lot of Wasm modules, interesting tools like Nginx, Apache, like Redis, some of the server tools can also run. We'll talk about it later. And these powerful libraries like OpenCV, TensorFlow.js, Kia, SQLite, and FFmpeg are also all ported to Wasm. So you don't need to compile them. They're already compiled to Wasm modules. You can just use them. And one nice example of it is FFmpeg. I was a user of FFmpeg. I use the command line a lot. I also use some server-based solutions using FFmpeg in the server. But I was always worried about my data leaking my videos or audios. It's a library that can process your audio and video. It can compress it, change the format, can stream it. And right now, you can do all this in the browser. So you can just load FFmpeg in a web app. And another benefit of this, there is no latency because you don't need a connection. You don't need to upload this data. You can load it from your file system and run this offline right into your web application. So it's secure in that aspect. You're also saving costs because it's client-side computing. You're not hitting servers for this compute. You can depend on client's computing power for that. Compiling a WASM module is possible with mscripton. It has been a critical actor for WASM success so far. It's a complete open source compiler toolchain for WebAssembly. So it compiles C and C++ code or any other language that uses low-level virtual machines into WASM. It compiles the C, C++ runtimes of other languages, like the PHP example that we saw. And it can practically port any C, C++ code base and compile it to WebAssembly by using mscripton. If you navigate to this link, you will see there is also some large engines, even like game engines, compiled to WASM that you can use it on the browser. How do we actually compile a WASM module? So this is a simple example of creating a Hello World text file. It creates Hello World text file under Hello World folder, writes Hello WASM, and creates an output. With mscripton, we call the command of emcc and then our C file. And as an output, we would like to have an HTML file. So by default, emcc creates a WASM output. And when you ask for an HTML output, it also creates the HTML file and a JavaScript glue file for us, which provides extra utilities and also bridge between this WASM and your web app. And emcc is a drop-in replacement for the C compilers. So like how you're using C compilers, you use emcc instead. And you can also convert some of the C, C++ based native libraries yourself if they are not ported to WASM yet. So if you found a small utility or like a library that solves a specific use case of yours, you can port it to the web by compiling it to yourself with mscript. There's two nice articles about it. Mscripton, a C library to WASM. It compiles a WebP encoder to WASM, libwebp for the web, and compiling MakeBitWeb to WebAssembly by Thomas Steiner. It compiles an image transformer to WASM, MakeBitmap for the web. So this also has some gotchas, so you need to see how you're actually using Makefiles and building the C source code for porting it to be compiled with the mscript in a good way. So I recommend going into these articles whenever you think this is the right way to do for your feature. And let's see the dreamers of today and the use case of WASM outside the browsers. So we talked about the WASM runtimes and browser mostly, but browsers are not the only runtimes for WASM. So you can actually run WASM modules without JavaScript itself, without any browser itself. So WASM initially was created for web, but you can also run it on desktop. You can run it through the command line. There are runtimes that can be executed on the command line, and there are also runtimes running on the edge servers. So these WASM runtimes, examples of the server use cases are Node.js and Dino, and command line use cases are WASMtime and WASMEdge, and WASMer, WASMEdge, and WASMtime, they are also used on the cloud. And how they are used in operating system, how WASM can interact with the file system or operating system. It actually uses something called WASI. WASI stands for WebAssembly System Interface. It's a modular system interface for WASM. It allows you to run WebAssembly outside of the browsers. It's designed to be independent of the browsers, so it doesn't depend on any web APIs or any JavaScript code at all. It's not limited by need to be compatible with JS. And it has these capabilities already. It can read and write. to I/O operations, program arguments, environment variable, hardware lock, random, and sockets. So WASI capability-based security system gets WebAssembly closer to the principle of least privilege. So it's also secure in that way. So you imagine the same example of writing the file. This time we are using a Rust example, and we are using cargo as a compiler for the Rust. We have this outcome, and we are using these command line arguments to map the directories to give the permission to this WASM module. So it doesn't have a direct access to your file system unless it's given to. It has the least privilege approach. And according to Solomon Hykes, who is the co-founder of Docker, if WASM and WASI existed in 2008, we wouldn't have needed to create a Docker. That's how important it is. WebAssembly on the server is the future of computing. And according to Cloud Native Computing Foundation, containers are the new normal and WebAssembly is the future. So why WASM and WASI is attractive? It's faster. WASM apps start faster than containers, and there's no cold start issue. If you're running AWS Lambda, you have like typically 300 milliseconds of cold start issue. With WASM running on the edge, it's 5 nanoseconds. It's like 6 million times faster. And smaller, you don't need to ship like a complete OCI container to run your application. It's more secure compared to containers allow by default fashion. It's deny by default, and it's portable because it doesn't care about the architecture. And now we are moving from PCs to VMs, containers, and Kubernetes, and WASM is the next in cloud native. So instead of running large operating systems in containers, you can focus on running your small WASM-based apps. And it's not limited to that. WASM is going beyond browsers by focusing on Cloud Edge, IoT and Far Edge, and plugins. For the plugins, Microsoft Flight Simulator's plugin system is based on WASM because it's portable enough for plugin systems. Also, Shopify Functions and Fastly Compute is using WASM for their plugin system. For IoT and Far Edge, I can give the example of Amazon Prime. They actually use WASM to ship their app and update it on 8,000 different device types. So it's portable enough to build the same application and update it on 8,000 different device types. And the performance was also improved. They improved the speed of the application by 25 times compared to JavaScript runtime. And Kotlin is also using this with WASM GC. WASM garbage collecting is a new API available in Chrome browsers, and it allows porting not only the business logic, but also the whole UI of Android to Swift environments. So you don't only share Android-specific logic with iOS, you can also share Android-based UI with your iOS applications thanks to WASM capabilities. And this is a nice example from WebLLM project. With WebLLM and WebGPU, you can actually run open source models of LLMs right into your browsers, working offline, not leaking any data to big tech. So this is an interesting project. Check it out, WebLLM address. And you can download any open source model directly, like Llama 3 here. And you can interact with your chat application right into your browser. Thank you very much.
So we don't have
with the BGS team on React Brussels, React Paris, and other conferences. So it's likely that you might meet me again at some other conference. I do quite a lot in a year. I also organize my own meetups in Ghent, Belgium. That's where I live. That's all about me that you got to know, I guess. But if there is more, feel free to reach out to me online. Cool. You're not here for me. You're here for Astro. So let's start with Astro. What is Astro? Who has heard of Astro and who has used Astro? Not too many. Okay, that's good because I'm here to explain it to you. And I'm going to start with the start. Astro is the website generator or the website framework for static websites or for content-driven websites, as we like to call them. This is some code. So I'll go out of the way. Maybe that's better. So as you can see, like at the top there is just plain TypeScript, JavaScript as usual. And below, it's a JSX-like framework. And this is actually the real code of my website. So it's pretty simple, super readable, uses Tailwind, whatever, blah, yada. And that's my website. So pretty. Not many people actually like it, but at least there is someone who thinks this is peak app development. So I'm happy. Cool. This you've seen. Fine. But actually, Astro, let me quickly go back. Yeah. So what is different about Astro? Well, it ships with 0 kilobytes of JavaScript by default. So if we take a look at this website, it's just a wireframe. All of these components in something like Next.js or Next require JavaScript to render. Why? We don't really need it since, for instance, the footer might be totally static. We really don't need that. So what Astro does is it takes all of those components, even though they might be written in React, which I'll come back on later, they will still be compiled to native HTML and CSS for the browser without any JavaScript. By default, that is. Now, that will give you super good performance, obviously, if you optimize it well for SEO as well, because otherwise SEO might be 0. Cool. Why do I say ideal for content-driven? Well, all of that is static, so very indexable, very fast for browsers, very fast for the user. But what if I need interactivity? What if I need buttons or I need something to happen? Well, that's where islands come in, or client directives. Client directives is one that you use to have islands. We have a couple of those. Client load, for instance, will always ship JavaScript to the component. Client idle will just wait for the browser main thread to be idle and then ship the JavaScript. You have client media, which will just respond to given media queries. So for instance, I want a button for my menu on mobile, but I only wanted to ship JavaScript if we're actually on a mobile device. Very useful. Client only just skip out of our complete compiler, so we don't need it. Now, so with that client hydration, or those client directives, we can bring this full static HTML website here to be interactive in some parts where we actually do need it. So this is super useful. For instance, the image slider might be client media because I only want it to work on desktop. Or maybe I want my header to load first and maybe my sidebar only when it's actually visible. You can totally do that. Now, you can also build your own because we're still Astro, we have a company behind it, but Astro is an open source project. So you can totally build and extend your own client directives. For instance, here, this is what my colleague Ben made, client when raining in New York. That basically means hydrate the component, but only when it's raining in New York. So that's pretty cool. We call this, as I said earlier, islands component architecture. Now, this is really cool. You can actually build on top of Astro with your own library. For instance, some here might use React, some here might use Vue, or maybe Cityjs because you're a hipster. You can do it all. You can choose which one you use, and Astro will be framework agnostic for you. Cool. That's why Astro is completely and full speed. We do a lot of releases. I don't know if anyone noticed that. We do a lot of them. And in Astro 2, we actually launched content collections. Content collections are basically a new way of working with Markdown. Markdown authoring. Who here has a blog? No, almost no one. Okay, interesting. Well, Astro might be very good for you because you can actually make everything type safe even though you're using just Markdown. Really interesting. That looks kind of like this. And of course, in your IDE, it also looks very handy and pretty. Cool. We brought hybrid rendering as well, which is super interesting because maybe you want to compile everything to static mode by default, but just have one API point for instance, a like. Give a like on something, or maybe record your views, or maybe you want to fetch something. That you can do with hybrid rendering. Or maybe the other way around. Like you want everything to be dynamic, but just one static page. You can totally do that. Astro 3 was really cool. One of our most hyped releases like online. And why? View transitions. Has anyone used view transitions yet? No. Cool. Okay. So as I mentioned, Astro by default is static, which means you have a multi-page application, an MPA, not an SPA like React or Vite. How they work? Actually, view transitions can transform your MPA to be looking like an SPA, but this actually is all different URLs. As you can't see it, but in the top you can see that it's different URLs. That's a really cool thing. The greatest thing about this all in Astro is it's only 2 lines of code. You just import it, put it in your head, you're done. That's free transitions on your website now. Now, it is really cool to see that the Chrome team has actually adopted some of it. And since Chrome 126, they will be shipping this for MPA websites to support view transitions. So it's just a CSS tag. Really easy to add as well. We also added image optimizing. So image optimizing is always a pain in the ass when you're doing web development. You might get a JPEG, you might get a PNG, you might not know the format. Well, we take that by default and transform it for you to a WebP, which is one of the most performant things on the internet, for image rendering at least. But what about picture? Of course, we have that as well. And picture is even cooler because you can have multiple different output formats. For instance, you can see here, there is 2 formats supported, like AVIF and WebP. So if you want to use WebP, over your browser is configured to use WebP, it will use WebP. If you want to use AVIF, it will use AVIF. And we do that all for you, so you don't have to do anything except saying, hey, I want these formats to be supported. Easy. Page partials, I'm going to go quickly over that. It just basically makes the HTML element itself disappear, the head element, the body element, all of that. It's just your simple component. And why is that useful? You can use HTMX if you want to inside of Astro. Now, Starlight is also something we shipped. And actually, I think I have a slide about it, so I'll wait. But Starlight is a docs generator with Astro. So you have all the Astro goodies, like the islands and all of it, but inside of like a documentation generator. So if you're used to something like Docusaurus, this is the same thing, but with Astro. And actually this week, we celebrated our first birthday with Astro Starlight. So yay! We're 1 year old, cool. Astro 4, latest one. Dev toolbar. People actually underestimate how complicated but also really good dev toolbars can be. For instance, here we can see the inspect tool, and the inspect tool will show me on any page that I'm on where my client components are, what the props are, what framework it might be using, where the file is located. So it's all inside of the browser. It's really easy to debug stuff while you're still in the browser. But also performance and accessibility, we do care. So this one will show you, oh, you forgot to add an L tag, or maybe you forgot to have an area thing somewhere. We will tell you about it right in the browser there. So really easy. Of course, you can also build your own extensions on that dev toolbar because we're open source by default. Content collection caching, really cool. So I was explaining about content collections earlier. And the problem with a lot of like static site generators is that you have a lot of content. For instance, our documentation, it's like 4,000 pages in, well, it's 4,000 pages if you include all the different languages. But what we do with content collection caching is only rebuild the pages that already have been altered. Everything else will stay in the cache. So by doing this on our own like 4,000 pages of documentation, we were able to get like an 80% in gains on just our build speed, which is amazing because that's also like cost pressing. Because if you're building for CI, you're paying for CI. Of course, that's not everything. What is next? Well, in short answer, you can decide. We have an open roadmap. So we typically take suggestions there. Oops, I was supposed to show that. So for instance, here are all of the RFCs. You can open discussions. You can open GitHub issues, and then we'll talk about it, and maybe we'll build your feature next. It's something that we regularly do. So that's cool. Now, want to see me code? No? Yes. Good. Tech team, I'm going to switch to this one. All right. Can you all still hear me? OK, good. So I've built this most amazing, difficult UI. Give me a second. I'll try to get it on the screen, because mirroring was not possible. So I really hope that I will be able to code fast, since it's really hard to read. All right. Sorry that I have my back to you. Really? I can try. If everything goes broken, I'm very sorry. Mouse. All right, there we go. Mirror. All right. Everything okay on stream and tech team? Yes? Good? Perfect. Okay. So this is the amazing, very difficult UI that I've built. It's just a guest book. So what is a guest book? Oh, yes, okay. A guest book is something that's just...
I will stop. You can share your screen to the live stream?
Isn't it shared anymore? It is. It should be.
So you can add it. Okay.
It's here?
Let's switch back to the set of text.
Switch back? All good?
Yeah.
Okay. Then I'll try to code like this. Where is my arc window? Whoops. Maximize. All right. So this is my difficult UI. As you could see, that's what I explained earlier. It's not that hard. So what I'm going to do is I'm going to install AstroDB. Well, I've already done that. And what I'm going to do, I want to make my comments dynamic. What if I actually, I'm not going to store them anywhere statically. That's not worth it. What I'm going to do is actually have a dynamic database behind it. So I'm going to my config here in my AstroDB thing, and I'm going to, oh God, it's hard to code like this, but I'll try. So I'm going to make a comment type. So a comment equals define a table with some properties. So that has some columns in a table. That's typically what we see. Maybe we want a title, and let's say that the title is a column, dot, let's do text. And maybe we want that to have a name, which is also a column dot text. And maybe we want a comment itself, like the body of the comment. So let's do that also, comment dot text, a lot of text here. But maybe we also want some likes. So let's do likes. That's then a number. Oops. Oh. Now I can't see anything anymore. Number. Cool. And then I'm going to make a created at. Like I want to know when everything was created. So created at will be a column, and that will be a date, and the date will have a default, as you would normally do. So let's add a default, and that will be now. We can import that from the server. That's really easy. And maybe also here, let's do a default 0. Cool. Let's import that table actually in our database. Oops, comment, I'm sorry. All right, let's check. Dev server starts. Cool. Now we have comments set up, but now we actually want to do something with those. So let me go in the index page and actually try to show them. Like here I have it statically set. It's really easy. It's just like you would do in any JSX, but of course you have to fetch them first. So I'm going to do is just const comments. Oops. And that is await, because you can do top-level await in AstroDB, from AstroDB, of course. And let's select from the comment table. And that's basically already it. Now I have my comment, so I'm going to do, before this one, I'll do comments.map with a comment, and then let's return some JSX. So in the comment, I'm going to write, whoops. So here we'll get the title. So C dot. Do you see that all of this is type save as well? Which is really handy, especially if you can only see the screen for half. So C dot, I guess that's the comment itself then. Let's go with C dot name. Oops. Post it on, and then we'll get the date. I'm just quickly, so I don't waste any time, I'm going to use just 2 local date string. So created at, and then let's do 2 local date string like this. And we have 0 likes. That's correct, but let's make that like the actual likes. So c.likes. Oops. All right, that's it. Cool. Now, of course, we have no actual data yet. So I'm going to quickly make some in the seed data. I'm going to have to check that after. So let's do the same thing. Await database.insert into comment with values. Let's make that actual an array with, can Copilot do this for me? No? Name. I'll do alien. It should actually be all type safe, but I don't know why it's, oh, I have not imported it yet. Whoop. It's really hard blind coding. Whoop. Title, hello world. And the only thing we have to fill in is the comment itself, because everything else is has a default value. So I'll do this is a comment. And if we restart the dev server now, which should be really fast, hey, there we have it. So that's just the seed, not too hard. Now, what if we actually want to add a comment? That's pretty difficult because it's a static website. Well, we're going to use a library for that called Solid, because I am a hipster. So we're going to make a component. So let's do form.tsx. Yes, I'm using TypeScript, of course. So export default function form. Yes, that looks good. It doesn't take any props and will return some HTML. So I'm quickly going to go to the index. No, not the index, the post page. I'm going to steal all of the code here and put it in. Hup. Now I'm going to use an action. An action is something experimental still in Astro, but it's really cool. So what I can do is on submit. So when I'm submitting this, I'll trigger a function, and let's make that an async function. What I'm going to do is call an action. So first I'm going to build the action, and the action is actually really simple. So we have comment here. What we're going to do is we're going to, ooh, that was not what I meant. What we're going to do is actually we're going to accept form data that we know already. So form, whoop, like that. We accept an input, and an input will be a Zod object. Has anyone used Zod here before? Yes, perfect. Well, we're going to use Zod. We export it from Astro Actions. So an object with, and that's basically the same thing as we gave in our database configuration thing. So let's do a title, which is a string. We're going, oh, that is also not what I had to do. We're going to have a name, which is also a string. We're going to have a comment, which is also a string. A lot of strings here. I know typically you wouldn't do that, but it's how it is. And then we already know that we can use them. So that's really easy. You just give them here in as props. So title, name, you'll see the autocomplete there, comment, done. And now we're just going to input it. So await database.insert into the comment. I think, nope, that's a different one. I'll just have to do it manually then. So import database comment from astro:/db. Perfect. So we know that we have it here. Values. Really easy. We'll just make it an object with title, name, comment. Cool. And now we go to our front end. We'll just say on submit. Let's do a default default prevent. Oh, other way around. Prevent default. Then we'll do some form data. So let's do const form equals new. I'm doing some magic here, don't worry. Form data from e.target, and the target is a HTML form element because we already know that. what we're going to do then is await actions dot comment. It already knows that we want to do that with form. Cool. Now, if we go back to the index, to the post page, I'm sorry. Let's go there. Now we import that form. So form, I'm going to client, load that. I have to import it then. So import form. Oh, was it there? All right. So now if I do this, we still have one comment. I'll go in there and I say, hello, I am Elian. My title is Cityjs is great. An awesome comment. And if I submit it now, there is no redirect because we didn't program that. But if I submit it, I clicked it once, it should be there. That's how easy it is. It's still a full static website. It's just that only API endpoint there that we exposed. So we can totally do a redirect. We can do it either in the form, or you can do it. My voice. I've been talking too much today again. You can actually also just on the handler do a dot on success. It's not documented yet, so that's why I'm not showing it. But also, like, what if I want to add likes? I know we have some likes here, but it's not there yet. We're going to build them. And it's actually way easier than you might think. So I'm going to make a new component. And let's call it like.tsx. I'm going to do it again. Export default function like. And actually, now we have to take some props in. So I'm going to add, props. Which ones do I need? Well, I need the ID, which is a number. And I need, what do I need? Probably the initial likes, because we need an initial state, and that's also a number. All right. Now I want to return a simple button, and it has likes in it. I'll program this later, what it actually does. Ooh, that's not what I wanted. Likes. And then let's quickly get in some signal. So let's do import create signal from from Solid.js. It's basically the same syntax as you're used to with useState. So likes, set likes, and that equals to create signal with the initial. I can read it. Props dot initial likes. Okay, so far makes sense? Good. I'm going to make that a type button. Come on. Button. And we're going to do something with that button, because on click, we're going to call the other action. So we know we have an event. We don't care about the event, but we do care that it's async. We are going to do it like this and just say await, and then the action, so actions dot like, and we'll pass in the input, which is the ID. We'll save that later in our action itself. So props, like this, props.id, and that's actually the ID prop. Cool. That will actually return something. We'll program this. So const updated likes equals that, and then let's say set likes to the updated likes. All right, you see this is not working because we haven't actually programmed the thing yet, the action, sorry. So let's do that. So here we don't have to accept a form. We're just going to do input. We take a z.object. I'm going to have to hurry here. I only have 3 minutes left. It's an object, and that object has that ID. We already know that, and that's z.number. Cool. Let's program that in. We need the ID. So what I'm going to do, and this might look a little bit insane, but it's how it is. Await the database, and we're going to select the initial comment. So select from comment, where the equals comment.id, I also have to program this in, is equals to the ID, then we'll get that one. So let's do const get comment. Now, what if we don't have a comment? So we have no comment here. Then we'll return or throw new error, whatever you want. Whatever. Cool. Then we'll update one. So const update comment, which is await, and then database dot update comment set. I hope I can read this. Okay, so set. I think I can do just values. Values. Oh, where's my type safety? Okay, set. Set the values. Yes, set likes to be equals to get comment dot likes plus 1. Okay, can I read this? I kind of can. Okay, so select comment doesn't work because comment actually doesn't have an ID. We're going to give it one in the config. It does have an internal ID, but not an exposed one. So let's give it one, which is a column dot number, and let's make that a primary key true. Cool. Let's restart the dev server. Now we have that. So let's quickly check if that will work now. So we probably have to import where the comment should be select y from comment. All right, we're here. So we get the comment, we do it plus like, and actually instead of updating this, we can return this as well. So let's do return the update comment object, and we want to do the like. So let's do returning. Ooh, am I going to get kicked off stage? Let's see.
5 minutes.
5 minutes. Oh, chill. I'll be good then. So we'll take.
Okay, 4.
Oh God. We'll take the likes here. Why is it not importing where? Well, it is here, right? Okay, we'll see. We'll see. If it works, it works. If it doesn't work, we'll see. So now we do that. Okay, that works. We actually want to import that here because we know that we can actually import it. So let's do like. So that's the component. We know it has an ID. So let's do the ID, which is c.id. And then we have the initial likes, which is, of course, c.likes. And we're going to client load that part as well. Oops, that's not what I wanted. All right, moment of truth. Is it going to work or not? I have a suspicion it won't. Hey, it does. So now it actually updates that. And all in time, and all in time. So now if I refresh that page, it's still 2 likes. So that's actually what you want. Quick show, like audit. Now I can see, oh, this is actually a button. And the prop is initial likes is 2, ID is 1. That's a really useful thing. Cool. Actually, I don't have a lot more to say, but I'll quickly go through the slides so I can have a beautiful ending. If you want to stay updated, like about Astro, you can go to astro.build. That's our website. We have a very active Discord, so if you ever try Astro and need some help, you can go in there. We have a newsletter. We have all official channels. Follow us on Twitter. Follow me on Twitter. Whatever. Thank you very much.
Thank you. We have our last break, so you can come back in 15 minutes. make an introduction better than what I will read because
Okay.
Nemanja was very helpful all day. So I will say, Vala.
Thank you.
And I think this is why I love this community. To be helpful and help each other is one of the guides. So thank you so much.
Thank you.
And probably you will be organizer next year for Cityjs, I'm not sure.
Probably.
So you are going to talk about scaling heights, highly scalable architecture with Next.js. So the stage is yours.
Thank you. I'm gonna need a mic. Yeah, thank you. Thank you very much. Okay, hello everyone and welcome. Following part is going to be a bit cringe, so I would ask you all to have a seat and fasten your seatbelts. Ladies and gentlemen, this is your captain speaking. Soon we are going to reach the altitude of scaling heights. Thank you for traveling with Next.js. Okay, now let's get this back to reality. Let's land this thing. That's the last one, I promise. My name is Nemanja, and today I'm going to be your guide or captain through this exploration into scalable web architectures. During my career, I had the unique opportunity to work in and live in both Switzerland and Germany, and now I'm located in Belgrade, Serbia, working as a front-end lead engineer, mostly with React and Next.js. Now, we're going to dive deep into how Next.js can help you transform your projects and enhance your scalability. But before that, I'm soon going to be 4 years working at Interventure, a company, nearshoring company that's headquartered in Zurich, Switzerland, with engineering hubs in both Romania and Serbia. During the last 12 years, they built more than 40 engineering teams for the clients from Germany, Switzerland, USA, and UK. I'm currently working closely with one of the company's clients located in Zurich, Switzerland, called New Wind. So if you're on the lookout for talented, dedicated developers, I'm your go-to guy, so feel free to reach out. Okay, and now let's jump for a bit into some really boring theory stuff that we need to go through. You can see the team also switched from light to dark. We will first go through web design principles for scalable architectures, but from a front-end perspective. Then we are going to see how Next.js tries to achieve these principles, but no worries, I will not bother you for too long with the stuff that you can actually read from the documentation. Main focus of this session is going to be to showcase you how we actually did it in our application and how we achieved highly scalable states. So, onto it. Let's start with modularity. So, the scalable architecture is built around the concept of modularity. You have the system that you break down into smaller independent components, and having this makes it much easier to understand, to develop, and to test the actual system. Next.js, like React-based framework, of course, promotes component-based architecture. And with this approach, it allows you to have reusable independent modules that, when pieced together, can create a really highly complex interfaces. Components can have their own logic and state, but they can also be purely functional, depending on what you pass down as props to them. Next.js also uses the file-based routing, which means that every single file that you placed in the pages directory is going to correspond to a route inside your application. If you decide to place a file into Pages API directory, that file immediately becomes an endpoint. And now, why is this approach cool? Because it allows you to handle your backend logic inside the same project structure, and in this way kind of promotes that cohesive and modular approach of handling both backend and frontend in unified manner. Next.js, of course, supports CSS modules, which allows you to localize your styles to an independent component. And in this way, it also promotes modularity in styling because it doesn't allow conflicts between the styles from other parts of the application. There is also support for dynamic imports with Webpack included, where you can load your modules and components when they're needed. And of course, last but not the least, there is middleware, which allows you to run code before the request is done. So imagine receiving a request. You can then rewrite it, redirect it, modify headers in both request and response, or you can just directly respond to the client. And the important thing to note is that middleware runs before cache content and before routes are matched. The second design principle is definitely rendering. And when it comes to rendering, you have different options. You can opt in for client side, server side, or have a hybrid approach. The goal at the end is basically the same: reduce the load on the client side. And with this, you're going to improve performance, you're going to improve your UX, and also SEO. If you have the opportunity when you're in the design phase of your application to see and to decide which parts of the application are not going to be that dynamic and where there's an opportunity to use something like SSG, like static site generation or server-side rendering, or even a hybrid approach, do it. It's going to be worth afterwards. Next.js supports SSG and SSR. Now let's see what is the difference between two of those. So with static site generation, on a request, during the build time, basically you have all of your data fetched and the page is generated, then that HTML is sent to the client on every single request. While we have the server-side rendering, where on every single request, data is being fetched again, and you're going to receive a different HTML. We also have a ISR as a hybrid approach that allows developers to use SSG as a flow, but then again, have some parts of the application or the pages that you can say, okay, let's add revalidation here, allow the possibility to update those parts, but only those parts if and when the new data is present in the background. I have created some images. I mean, I have picked up some images from the really good online source where you can actually see how this works. On the client, so during the build phase with SSG, you can see that we have compilation, we have data fetching and page generation. And then on every single request from the client, you get the same HTML and CSS plus JS, of course. With server-side rendering, it's a bit different. Here we have on every single request, so the compilation is the only thing that's done during the build time, and here we have that on each request, you're again fetching the data, getting the data back, generating the HTML, and sending it to the client. And now with ISR, ISR allows you to have the same flow, the same SSG flow at the beginning, but then have parts of the pages left for revalidation. So when the client requests the page, if there is new data available for those parts of the pages that have the active revalidation, you're going to get updated data. Okay, let's move on. Data fetching. I'm not going to spend too many words since Faris did a great presentation today. The important thing here is overall to choose the right strategy. If you're going for the server-side fetching or the client-side fetching, it's really important because in the long run, it's going to make really high impact on your scalability. Having it on the server side, it's going to reduce the load on the client side. It's going to reduce the data transmission costs. But on the other hand, if you have it on the client side, you can reduce the server load and have server focus its own resources for other tasks. Next.js has a few options when it comes to data fetching. The first one that is used with SSG is get static props, which gets the data during the build time and generates HTML. The data that is fetched is embedded into the HTML and returned to the client. We have get server-side props, function that runs on each request to the server. It fetches the data and then passes it as a prop to the React component, it renders the page on the server, and returns it back to the client. We have also some cool options like get static paths, where you can, when you're working with like dynamic content, you have the option to set which of the paths are going to be static in your application. You, of course, have client-side data fetching with React hooks, where you can use Fetch API, Axios, or whatever you prefer. We have ISR there, which I already mentioned. Not going to go too deep into it, but there's an option to reload the data and have some parts of the pages. Like, for example, if you're creating an application like a stock exchange or news portal, this is a really cool thing to have because you can only have one part of the application being revalidated and the data being updated, while rest of it is static. And we, of course, have API routes, which I'm going to showcase a bit later when I'm going through how we actually did it and our example. Okay, now state management. And the big question, is stateless an option? And here I specifically mean like global state. Is it possible to go without the global state? My advice is yes. You should try to keep your state local to your components wherever you can. In that way, you're going to remove the need for expensive and complex state updates, state reads, having like an additional global state management library on top of your code, huge centralized store, and other stuff. But of course, there's not always an option to go without. And if you really need to use it, Next.js itself does not prescribe a specific state management library, but it is compatible with most of the most popular ones, like Redux, Mobix, TwoStand, and others. I will quickly show you what we did with Redux in our application and how that relation ended. Okay, but let's just like quickly go through the last design principle, which is performance. Many of the things that I already mentioned have a big impact on the performance. However, it is also worth mentioning code splitting, bundling, image dust optimization, lazy loading, CSS processing, and many other things. The goal here is to utilize every single tool that you have on your disposal to reach maximum in all of these, because at the beginning it may not seem, but afterwards it will have a really great impact on your performance and scalability. Next.js comes automatically with included Webpack and Babel, of course, before version 12, which means that the code compiling and code splitting is done automatically by the framework. Since version 12, they moved to TurboPack and SWC with the like Rust-based tools, which I know that many didn't like, but documentation claims that SWC is 17 times faster than Babel. And of course, there's like a set of predefined components that come with Next.js, like link, image, and many others. Image, for example, is cool because it automatically optimizes your images, allowing you to use modern formats like WebP. Okay, now let's go to the real world thing and the real world example. So in our application, we're currently using Pages router, but many of these things that I will talk about are also applicable for the app router. And just another note is that we did kind of like, let's say, good research before deciding what to do and what to use with our application, which does mean that it is going to work and it is going to be a best solution for every single architecture out there. Okay, the first one, middleware as a control station. Maybe not like such like a general approach, but when we started building the application, we started with Redux. And after 3 months, our centralized store grew so big that it was really hard to, like with the agile application where things are constantly changing, it was really hard to keep track, to update, it was wasting too much time. So we decided to completely remove it and to go, instead of centralized, to go with decentralized architecture. I'm going to show you some things that we use middleware for. The first example is we are checking, actually, like we're not doing this in API routes, we are doing this in middleware. We are checking if the user actually has token. This kind of allows us to handle the whole unauthenticated flow inside the middleware with these 4 lines of code. This also saves us of wrapping your components into like higher order components to check like if the authentication, if the token is there. We decided for this approach and currently it is working for us. The second cool thing that we use middleware for is multi-language. The code was too big to put on one slide. Since we have like 3 different languages and we have 3 different, let's say, requirements when we were building the multi-language for the application. We had the user settings that was on the third-party identity provider.
we had the actual language that was set by the user inside the browser, and we also had, if the user is logging in the first time, doesn't have any settings, it didn't change language, it needs to come from the browser in its headers. We are handling everything in like 20, 30 lines of code inside the middleware. One more thing is like all different, let's say, custom pages that you have in your application. For example, in our application, which is multi-tenant application, we are using tenants as a dynamic part of the route. And now, when somebody tries to access a tenant that doesn't exist, that is not automatically 404. Why? Because the route is still valid. You're accessing, dynamic part of the route is still there, the route is completely valid, and that means that you shouldn't be redirected to the 404 page, right? Here we did different things. So we basically are sending a request from the middleware. So we are intercepting a request. We are sending another request to ask if the specific tenant exists. And if the tenant exists, we are returning the user and saying, OK, you can proceed. If not, you're going to a specific not found tenant page. One more additional cool thing is that we also have the users that are logged in that can have accounts with multiple tenants. And from here, we can allow user to go directly to a custom page to log in with a different tenant if that is an option. OK, now you can probably ask me, OK, but what if I don't want middleware to run on some parts of the pages? What, for example, if I have a public part of the application where I don't want to check for tokens, I don't want to check multi-language or other stuff, you here have a config that you can put inside the middleware where you basically specify on which pages your middleware is not going to run. OK. The second thing is component modularity and reusability. When we were starting with the work here, we realized we are going to have a huge set of components, really a huge one. Like we went through all of the designs, and then we decided to use, after a bit of research, to use atomic design methodology that breaks design into small items, which again then form molecules and then organisms. Here you can see the structure that we have, and here you can see that we have actually like a huge list of components, and this is just molecules folder open. So atoms was on like 2, 3 different slides. Why did we do this? Why was this really helpful to us? Because, like, first of all, it was easier UI testing, much easier UI testing, where you can test just those independent components, and you can run your UI tests, and everything was like pretty fast to implement. The second thing was easier styling. Here, for example, we didn't use CSS modules. We used styled components with React Material UI, and it worked perfectly for us. Like all the style files are inside these folders, so if you want to change something, you change it directly for that component, and it doesn't conflict with any other part of the CSS in the application. And the third thing, of course, easier typing, where you don't have to use global types or place types in like a store folder or like wherever it is. You can just like have it here, located and localized only for that specific component. The third thing was Next.js API routes. This part is a bit different than what we have right now in the app router, where you can still use API folder. However, API routes are replaced with route handlers, but that's for some other talk. Here is our current API structure, and here you can see that we have some complex APIs with dynamic paths. We have some simple ones, and I can show you now, I can show you now that it is here, next auth. We're using next auth for the authentication. At the start, when we created the project, since the backend was done in .NET, there was a logical solution to go with Identity Provider 4 and OIDC Client.js. I don't know if anybody here used those, but they pretty soon they went out of maintenance, and that kind of like highly popular solution for the auth was just like gone completely. We needed to switch, and we decided to go with the next auth because at that time we were a small team. It was like really heavy for us to develop our own custom solution or to go with some custom-based solution based on Passport.js. So this next auth introduced some limitations, but at the end it worked a great deal for us. I can show you now quickly. This is one of the testing requests that was like done a while ago. where we are testing only the public. This is just like the basic handler that is inside the API folder. So one API file endpoint. You can see that it's pretty simple and that from here you can basically control whatever you want. Here, this one is simple. We didn't even check for the token. This is done on the public pages. And here we have a bit of a more complex one where we were actually checking also the validity of the token. So the important thing to note here that the actual checking if the token is present is done when you request for a page and is done with middleware, which redirects you then to the no access page. But here we are checking the actual validity of the token. So we kind of relieved partly this part of the application by using the middleware. Then we don't have any global state. We have like a really huge application right now. And once we removed the Redux, we focused mostly on local state inside the components. And of course, usage of the following when that was not enough. Middleware, I already discussed. We use cookies. I know it's not that popular, but we use it like for really simple stuff, like user role in the front end in the browser, or having a language locale set there. We use URL params, of course, that are there for the, let's say you're editing a task, you're editing a user, you can pick up the ID from the params. You don't need to have any local state inside, like even and pass it down then as a props to other components. You can basically just use it from there. And of course, local page and local state for everything else. Now we come at the end at the aspect of security, where I can discuss a bit how we do this like process of authentication. So basically, we're using third identity party provider. We're using Keycloak in our application, which means that all the login and registration is not done inside the application. It is done on the Keycloak inside the tenant realm that is set up for the specific tenant. Once the user is logged in or registered, it is redirected back to the application with its own active access token and session to be used on the server side for accessing the other APIs that we have in .NET and get the data directly from the database. This kind of enabled us to have really good security in terms of no access token, no sensitive session or user data is ever reaching a browser. Everything is done completely on server, and from the server, we basically control the whole application and control what is being served to the client. I'm going to mention like here the thing that I already discussed with Nextauth. One of the specific limitations that arrived, I don't know if anybody came to that issue. I know that it is still open on Next.js repo, like many of them. But there was a limitation in terms of Next.js using those internal variables, internal environment variables that basically Nextauth also uses. And we had that there like a conflicting thing where we couldn't use subdomains, for example, for like assigning tenants. So we had to put that in the route. At the end, it wasn't a bad solution for us because it allowed us from middleware to check if the tenant exists and to manipulate with those tenants that we receive. But again, if you're like forced to do something and you don't have any other options, you don't feel that's like good with it. Okay, and I believe that's kind of it. I tried to fit 3 years of development into these 20, 25 minutes of talk. So I hope you enjoyed it. If you have any questions, you can reach me on my networks and yeah, or reach me here.
For you, I will have questions.
Okay.
Node.js core committer, keynote speaker, and professional educator, and he's gonna talk about how we can recreate Node.js.
Test runner.
Test runner, okay, let's see.
I need a microphone. Hello, my friends. Are you sleeping? Oh, come on. How are you doing? Woo! I brought some crazy stuff here, so I'm gonna last your energy here, right? So this talk is about recreating Node.js test runner. So obviously, I had to recreate the Node test runner for making this talk. So it was one of the hardest things in my life to make it. I hope you like it. All the resources here are already on GitHub. The slides I'm going to provide you at the end too. So, but feel free to take as many pictures as you can. Mention me, mention the event. This helps us a lot with the work we've been doing. All right. So I have some goals today. And I always talk about this because I know it's a lot of talks, a lot of content. And sometimes it's hard to absorb everything here. So this is why I prepared the link later, and I'm going to send you on your mail all the resources to help you. So this talk was made to show you the magic behind the scenes, right? How Node.js is so powerful, why we've seen so many runtimes appearing, libraries, or features in the Node.js core. I'm going to show too some ideas for you to give even more value for those who work on open source, right? Because they or us, I'm part of the Node.js core too. We've been doing a lot of work behind the scenes, and sometimes we just use, but we don't know how hard it is to create this and how we abstract the complexity. So it's a big shout out for all friends who's in open source development. And I need to give you some ideas and why you should recreate things from scratch. It's not something about production or just using everywhere. But it's something for you to think about it, right? Why we have Webpack, why we have ESLint, why we have so many tools and some tooling that is appearing right there, and how other tools like Dino, Bun, Cloudflare Workers, they are all helping Node.js to create these things. So it's a lot of things. Okay, part of this is part of my YouTube channel. So my YouTube channel, I've been doing a lot of these crazy experiments, like this talk. I think I'm going to make a video later because it was pretty hard to make. But I've been making a lot of specific questions, like, what if I recreate the ESLint? How ESLint is made behind the scenes? And then I figure out, my God, it's a lot of things. It's analyzing how JavaScript works behind the scenes. It's analyzing the syntax. So it's pretty great. The other thing was trying to recreate Uglify.js, generating source maps, minifying code, and doing a lot of crazy stuff there too. And one of my popular videos there was re-implementing the WebSocket protocol. So using binary codes, my God, it was really painful. And I think one of the craziest one, and I gave this talk, I gave a talk about this, was recreating Node.js from scratch. Has anyone seen this before? Nice. I gave this talk in Cityjs, London, so it was pretty fun. And let's see. So the whole goal here is to understand the magic, right? To understand why Node.js has a test runner, why. So Node.js is there since 2009, and why just now we have the test runner? It's crazy to think about it. Before I go on, just let me know how many of you has used the Node.js test runner. Wow, just a few people. Yeah. Let's see if I can change your mind to stop using some competitors and start using the Node.js test runner. Okay, after recreating all those things, I was thinking, okay, we've seen test runners appearing right there, right? We've seen VTest, we saw Node test runner, we saw Bun creating from scratch. So I got some ideas like, yeah, I should recreate one just to see how hard or how easy this could be. And it turned out it wasn't that hard, but it's a lot of work. It's the effort involved on this that it's hard. And Node.js is amazing, right? I would say since Node.js 18, I don't know, things are going too fast. We changed the website, so there you could see the docs later. You can see more blog posts, and it's crazy seeing how those competitors have been, I would say, motivating or sharing ideas so Node.js can improve and we can add more and more ideas. Well, not a while ago, I solved a bug in the Node.js core, and I finally joined the organization, and I feel so happy there. It's a volunteer work, but for me it means a lot. Well, the test runner is there, and the test runner, differently than a lot of people think, they are not just experimental, right? It's stable, so you can start using right away. I would say 90% of the features that you wish to see on a test runner is already there, but there's a lot of work going on. And this was my kid, right? So this is the first thing I implemented from scratch on Node.js. So I implemented the mock timers. It's very similar to fake timers on sign-on, on Jest. Has anyone worked with fake timers or mock timers? Amazing. It's an ability for you to move in time without having to wait, right? So you can trigger a set timeout without having to wait for it, so you can do everything basically synchronously. Okay, the first thing when I saw there, I've been working as a software developer for almost 10 years, and I was like, well, I'm gonna use the for to dispatch these timers, and I'm gonna just try doing this, like enqueuing the messages or enqueuing the functions, and I'm gonna just disappear or send later. So here, this piece of code just get all the timers you have. So you have, let's say, a set timeout with 1 second and a set timeout with 2 seconds. So probably the set timeout that must execute first is the lower time, right? The 1 second. So I was just running here, and I got a review in the PR. No. Node.js has a lot of algorithms built in that you can use that is way faster than this way that you are doing. So going there, they recommended me to try using things that are already on the Node.js core. So I would say this is why the Node test runner is 10 times faster than a lot of other test runners out there. Because Node.js is C++, right? So we can interrupt, we can start using functions, and everything that is already there for a long time. So on my pull request, I got some pretty cool stuff. So they said, well, go there and look at the priority queue. Has anyone seen this algorithm before? Well, this was the first time I saw it, but basically the priority queue, I would add my functions there, my timers, by the priority order. So on the top, I always have the lower time to just execute it. I don't have to go around on the list. I don't have to find it. I don't have to filter. When I'm sorting the data in the order of the priority. So I started using right away, and my code looked like this. Right now, I have this very specific function, but I have pick just to get the first item on the list, and I am executing, removing this from the list, and just executing. Well, this exploded in my mind, right? Blow me away because, well, what if most of the other packages we are implementing from scratch, we're using regular code, but what if we could just reuse code that is around there for 10 years and it's way faster than we think right now? It's crazy, isn't it? Okay. So this is the piece of code. And when we start recreating things, we think like, okay, test runner is a feature to execute tests. But in my mind, it was like, wow, there are a lot of components, there are a lot of topics that I never thought about. There are complexities and challenges that we should take care or we should think about it. Well, first of all, you need a CLI, right? So Node.js is just the keyword node is the CLI we use with --test to execute it. So the test runner has the CLI inside it. But if you want to recreate it from scratch, we're going to need to recreate or to build up a CLI as well. So going through the components, we start giving names to all of them. The first component is the execution engine. It's basically the one that's going to load your folder and start executing each individual test. By default, Node.js has to execute it in parallel. Node.js takes each different file in a new process, so you can run all of them really, really fast. And in Node.js, right now, we just use Node. I'm using the new experimental test coverage. I have the flag for test, and I just send a test. So this is basically the CLI that we have there to execute our code, to execute our functions. Well, the other thing is reporting. My God, this is, I would say, is the most effort that we should do, right? You are handling strings. There are reporters that prints out your test results as XML, as HTML. So there are a lot of complexities right there just to print out the results. And in Node.js, we've seen a lot of them. We've seen tap, which is one of the most popular around there. We've seen spec, dot, JUnit. Crazy, isn't it? JUnit ain't Node.js built-in. But yeah, it's already there. It works quite fine. And you can even create your own your own spec, your own reporter. You can extend it so you can use on SonarQube, you can use on other CLIs, or just print out as you wish. It's pretty good, this API. Well, basically, we have the result here, right? So we can see which task is passing, how long it took. We can see the errors, if there's any of them. We can see the file. Pretty basic, right? Every test runner is doing this, and there's nothing special about this. But if you look at the code in the Node.js core, you're going to see like hundreds and hundreds of lines just to make those reporters work. All right, now I'm going to talk something that we've seen a lot in our daily lives. Let's get some water. Oh. So first of all, who's here has been using Jest for testing? Ooh. I mean, Jest is good. Jest is good, right? It's been there since 2013 and more. Who's here is working with VTest? Ooh. Just so you know, I'm not here to create like technology wars, right? You use whatever you wish or what is better. However, you should give a try in Node.js core, in the Node.js test runner, because, I mean, it's going to blow your mind. It's really fast. When I had a YouTube video there that I was comparing and migrating from one to another, and I had like 10 times the difference of this. But there are a lot of reasons of this. It's the same thing that we've seen with Dino and Bun. They're saying, well, we are way faster than Node.js, and this, and that. But it's not fair, right? It's like you get all the ideas, or you get all of the problems, or things that didn't work, or things that worked, and you start implementing right away. So you reuse all this stuff. So, okay. The first component is the test suite itself, okay? The test suite for us as a developer is just the describe. So for each describe in Node.js, you're going to have tests around there. You can divide better, and you can see it logging on your code by context, right? You have like a very good hierarchy working there. We also have test cases. So test cases, so it's actually your use case, right? It's the actual test that if it fails, we're going to see on the report working right there. And it's pretty straightforward as well. Other thing are the hooks. One thing about the hooks is, when I start implementing this, we're thinking, okay, how can I make Node.js execute a function first without declaring it? It's crazy. Imagine this. We have before each, we have after each. So this means, imagine before running a test, I want to clean up my database. I want to create users, run a C, and so on and so forth. Or after each test, I want to clean up. But the first challenge we may see here is they are global variables, right? We don't have objects. So how are they linked? This is something that I've got in my mind. How can I say that the before is going to execute before the it? Because the it function should be the last one to be executed. I'm going to answer this later with some live code. Do you like live code? Ooh, you guys are mad. I was thinking I'm going to do some video, but I'm like, you know what? Let's try seeing live code and let's see how this works. So yeah, live code is always terrifying, right? But let's see how this will work. Before we jump to the live code, I think just summarizing the whole idea, we need an executor. So we have the CLI there that's going to load our folder. We have the JS API, which is the actual code that we are writing on our code, on our tests. And we have a reporter. With those three, you can create your own test runner and try competing with JS or others. Well, I had a bunch of challenges when building these things. And I'm going to jump showing how I solved them. And then I'm going to go to the actual source code. So first of all, parallelism. So for each file that I have there, so imagine each file has 100 tasks. They are executing in parallel. So how I'm going to log all of them like in order? If you see the reporters, you're going to see the file 1 is printing all of the things in order. You're going to see, and it's crazy. It's crazy. But for solving this problem, we're going to use that. For me, it's the most incredible API in Node.js to solve this problem. So this API I'm going to show you too, it's something that helps for both reasons. Working with async context. So what is the async context in this case? Imagine we are creating our code there. We have a bunch of features, right? We have the describe, and we created an it inside it. If the it fails, how do I know that this belongs to the describe, right? Because we need the whole tree back to report to the user. So we need some way to track this and get along with the results. So you can see there, I have a describe. Inside the describe, I would have a bunch of its. If this update fails, it shouldn't log the first get because it's not related. It's related to the patch and so on, so forth. To root this, we can use one of the most incredible APIs in Node.js, async hooks. Has anyone seen this API before? Wow, 3 persons in the whole audience. It's crazy, isn't it? Probably those guys are working with some performance monitoring or something related. This API I found pretty complex to analyze, and this is what makes Node.js slow. Ooh, a hard thing to say, right? It's slow in Node.js parameters, right? Or filters there. What happened here? Using Node.js, you can create a single function that is going to receive all async iterations your application has had. Now imagine, every time you create a promise, every time you receive a request, you can go through this function to log results and see those results and report them on performance monitoring application and so on, so forth. So I found this pretty complex. They have like docs there, but the docs for me wasn't pretty clear. But for using them, I would like to use async storage. So this API, async local storage, is like an abstraction for our API, and now it's way easier to work. So I can instantiate this function. I can say that I'm saving something on the storage, and then I can catch it later. But look, the problem with Node.js, we've seen a lot of people saying, well, everything that's going to be executed, we have an event loop. We don't have like a multi-threading system to organize those functions. So if I have a global variable here, saving the ID of the user or the user or just the request, probably I'm going to have like a racy condition error and a bunch of problems. But here, what I'm doing is basically creating a session that tracks all the asynchronous activity of the user just with this simple code. So when I have a global problem, look at this, it's a global. I don't have anything related to the user. So I can get the store without passing any ID. See, Node.js knows exactly what is related to that user. And then one of the coolest thing, I can use the response and reply to the user. So this means your application is never going to crash anymore, because you can get the user, you can get the object, reply to them, and just keep replying to the new users. Incredible. So we have reporting as well. And let's see the live coding, how it's going to work. All right. Well, basically, I created a full project there. Let me see if I can open here. Oh. Are you awake? Perfect. All right. So I'm going to do it pretty quickly. We have 5 minutes remaining. All right. Let me increase this zoom here. So as I told you, everything here I already published on the GitHub, so you can take a look later. But let's go through each individual step here. So I have this app, which is spoiler right now. Let's go to the runner. Let's see if the zoom is okay. So as I told you, we have 2 different components, right? We have the API, which I'm calling here the module, and we have the executor. So the executor is this bin folder. All right. So basically, the executor, it's going to do something pretty simple, pretty straightforward for us. It's going to try loading all the files we have there and sending to another class so they can be executed in parallel. So what I'm going to do here, if I go to the test runner, why I have something here. When I'm executing this, I'm just spawning a child process for each individual file. Surely, when we are doing Node.js can handle the memory and do all the tweaks for you. But here's just an experiment, right? So I'm running, waiting for those messages. And here, I can wait and I can synchronize the order of the results. OK, I'm gonna just scroll this a bit and show how it's done. Well, once I have the executor, I have to execute the files, right? So going back there, we need an API. So the users can have the hooks, can have the proper API so we can start using. OK, I'm going to go through now to the other side, to the Node.js API. So let's see how it looks like. So if we take a look at the code, we're going to see I'm just importing all the hooks that I'm going to use in this file. So I have the module.js here. I didn't install anything there. This is 0 libraries code. This is something nice. But here, I have all the hooks. I have the before it, before, after it. I implemented also a diagnostic function like Node.js is doing. And I'm doing the deep-street equal exactly as we've been using in another tools or in Node.js itself. OK, to implement this, we can see the test runner itself. And here is where the magic happens. So I won't going to go to the describe yet, because this is the hacking thing. But something that we understand first. When we are declaring it, we are not executing it. This is why we can execute in the future. And we can execute first the before or after some execution. So here, I'm just accumulating, adding to some function, but then when I have the actual suite, I can execute it. So for all those hooks, I'm just adding to a list, nothing special. When I have some message to send to the main process, I just use process send, but here is exactly the same thing for all of them. You can think as if you have one hook, you just can copy and paste it right away to start using. And to see this in practice, we can see we have the run suite. I run all befores I have for that specific context. I have the before each, and so on, so forth. Remember I told you about async hooks? Let's see how it's working in practice. So async hooks is right I think it's named Starch. Look how amazing is this. I can use the context get, so it doesn't matter ID, it doesn't matter where it came from. I just get the store. Node.js is smart enough to go there and retrieve all the context for me. Why we need the context? Because if I'm using an it inside the describe, I should print out, well, this it belongs to this describe. So this is how we are doing. So in this case, I'm using run. I execute the actual describe because it's the first function, and then I just start executing the others. Amazing, isn't it? Well, I think you are a bit curious to see how it's working in practice. So I'm going to press F5. And my God, this is amazing. Let's see here. Pretty hacky stuff, but you can see there. I built a reporter very similar to the Node.js core. We can see the errors. And the most important thing here, I can see where this error belongs. Test fails. Okay, test fails is there, and I have the message related to it. Remember the logs problem? If we are executing parallel, this might be hard to understand which one is calling what. Okay, just to jump to the final part where I built an actual application to try using my test runner to see if it works. I'm going to show you the reporter. I'm going to be honest with you. I built this reporter with our friend, ChatGPT, right? So, by the way, we have a very interesting new API in Node.js, so you can print out results colorful. And here, I just used a reporter to print out, generate the summary, but this is not the code I got from ChatGPT. The formatter is the thing. My God, this is smells, right? My God, it's ugly, but it works fine. Basically, I'm creating the whole tree to understand who is coming first, who is going to be last, and then I can see those results and see to print out colorful, I just use gray, green, and so on and so forth. All right, I'm going to show this code later for you. I'm going to give you the link so you can run it. But let's see this application that I made so we can finish the live demo here. Well, an actual application have database, we have HUE tests. It's a lot of complexity around this, right? So let's see the test first before we spoil everything. So I'm working on HUE test, right? So before each test, I can go there and say, well, initialize my server. Wait. I think this is not after each, not before each. It's before and after. So before the suite runs, I'm going to execute both of them. Let's see if it's there. Perfect. So before the code, everything happens, I'm going to just execute the code, just run my server. And after all, I'm going to just close the server. And you can see here, I'm using run seed. This means that before everything, I'm going to just clean up the database and execute it. Talking about the test itself, it's pretty straightforward, as we've been doing in any other language or any other test runner. I just have the input. I just check with deep strict equal, which is native in Node.js. So you feel here that you are in the Node.js core. All right, let's run this. Oh, I have some error here. Let's see. All right, I'm going to stop the debugger, and I'm going to run it. Oh, my God, let's see. Well, we have some error. The import. We have two of them. Let's see. Before. Oh, you are. OK, I think if I save it, it's going to run away or not. Let's see. So the burger attached. Let's see if I'm not in the correct folder. Just a sec. No, app, npm test. Let's see. Oh, I need to execute the database first, right? All right. The database is right there, so I'm not lying, and I'm gonna run the test. And wow, we have everything working, right? We have one passing test. I don't know why, but this is what happens when we are working, right? So this works as we are in production and as we are working in any other language, okay? So before I finish, I got to know Node.js Test Runner is amazing. Try it out. And if you want to get this content, just go to this link and I'm gonna show you everything on your email. I'm gonna send a document with all the studies and everything I've been doing right there. Okay? Just to enjoy this last moment, let's take a selfie, right? Woohoo!
It's all my idea.
Yeah.
I want to do it afterwards.
No, we do it again. All right, I'm gonna count on 3 and we just scream, okay? Yeah, let's make some noise. We need some energy. All right, 1, 2, 3. Hey! Thank you so much, Cityjs.
engineering manager at Single Store. I did it correct the last name and then I messed it up on the other. Okay, so what I wish I had known about front-end user tracking. Okay, go ahead.
Hey, okay. Hey everyone. So at SingleStore, we have been trying to draw insights from data to improve our user experience based on this kind of data. So as you can imagine, we need to collect a lot of data based on user interactions and on the client side flow. So today I'm going to ask you, by a show of hands, who uses analytics at their product or company? Okay, that's nice. And who feels like knowing the ins and outs of the analytics? Okay, yeah. So today I'm going to share with you what I wish I had known about front-end user tracking. So I'm Marta. I'm an engineering manager at SingleStore. I'm from Portugal. And SingleStore is a database that powers both analytics and transactional workloads. And we have the option to use it on premises. So if you deploy on your own servers or on the cloud. So you can just sign up and start using. In a couple of seconds, you have SingleStore deployed and running in the cloud for free. So I encourage everyone to give it a try. And jumping on the analytics topic, to give you some context. So as I was saying, we have the cloud option. So we have a web application and we have our website and public-facing documentation. So a lot of applications. And these applications connect to Segment and through Segment to integrate with all the services we're using for analytics. So they are Mixpanel, Google Analytics, Sentry, and some other services. And by using Segment, we don't need to make changes in our code or deploy a new version if we want to make any change to these integrated services. So Segment has been a real lifesaver for us. And this leads me to my first advice, which is if you can afford, use a tool like Segment. So I'm not here to advertise Segment. There are a lot of other options like PostHog or Heap, Phantom Analytics. So there are a lot of options that you can consider, but consider using one tool that help you managing your analytics workloads. And another thing that I learned is that you can track usage even before sign up. So this kind of tools have a feature called Anonymous ID. And if you don't use the Anonymous ID, you can track the data before the sign up. And then after the sign up, you know who the users are and you have the flow and the data about their interactions. But you can't correct.
Although if you're using this anonymous ID feature, after basically the tool generates an ID that it's saved on the client side, and when the user signs up, and then we have the unique ID that we are going to use for the whole flow of analytics. The tool, in this case Segment, just correlates the ID that was generated here with a unique ID that we are going to use further. And this means that you have access to the big picture, and we know that what user did before signing up. So which pages in our website they visited, or the documentation, wherever you want to track, you can track it. But these tools don't do everything, right? We still need to code something. And this leads me to my next advice, code-wise, which is build a common analytics library from day one. And this has worked for us. And let me show an example. So you can have, for example, your cookies banner or your logic to track the events in a library, and this makes it way easier to share and to share the logic between all components. And we all know the perks of reusable code. So if you want to go a step further, you can create a package for this, and you can even reuse it across all of your products or projects, and this becomes even better because you have everything centralized in just one place. And now you might be thinking that you need a super complex API or building a lot of, writing a lot of code. But my next advice is build the API that suits your needs in the near future. So especially if you have a product in an early stage, and event tracking is very likely to be forgotten, and developers don't want to spend a lot of time with this, make it easy. Build this culture around data first, and then worry about the structure and the complexity. And this is the example of our track function in the beginning. So we were just accepting a name ID and a bunch of properties, no structure, no validation, and it worked. But then we felt like we were needing some validation and some structure because we had a lot of features and a lot of events. It was hard to find them. So if you feel like you're in a point where you already have this data culture foster and you need this more mature API, then you might want to consider to have a proper structured schema and a function that accepts some kind of params and it's validated. And this was the example that we migrated after. So this is all about the params, but we need to give a name to the event. And I just want to warn you about this because think very carefully about your event naming, because the event naming is like the ID of the event. So it's what you need to correlate all the data, to build the dashboards and the reports. And every time you change this name, you lose the power to easily correlate the data. So if you're changing the event name every week, it's hard to build a dashboard where you can see the events and the results of the user interactions in a month or a year. And so most of the tools break this, but there are some that have some features. So always look at what the tool you're using offers and try to understand how can you implement this. And most of the tools allow you to export a list of the events you have implemented and consult all the events that you have. So you don't need to have a Google spreadsheet with all the namings as we did. And it didn't work. So when you are creating this culture around data, my next advice is to try to leverage a code review for analytics as well. And try to include this in the review you're making to your team merge requests. And especially because the developer might be too focused on the functionality and it's easy to miss the analytics, try to remind them to add or to contribute with other properties that might be useful or different naming, and bring your feedback for analytics as well. If you have a feature release checklist or a definition of them, you can also add it there as it makes it easier to not forget. And most of the tools offer a debugger, which is really useful to find the events you're using. So if you want to mimic a flow in production or locally when you are implementing, you can just interact with your application and see the events that are fired in this debugger. So this is segment debugger, but most of the tools
offer one, and you can see in real time the events you're firing while interacting with your application. And this is extremely useful for non-engineers that just want to build dashboards, like product managers or designers, and they can just interact with your application and see the list of events they need to build their dashboard against. And when you're implementing, you can also do that. So it's actually useful for everyone. And now you might be thinking that, okay, but my data wouldn't my data be polluted with all the local dev testing and staging and everything in the same source? And my answer is no. If you use different sources or environments for development and staging, or even if you want to filter that out, most of the tools allow you to do that. So we actually use a source for development and staging and another one for production. So we are sure that we are not messing with production data, and we are looking only at development and staging. So this has been really useful for that. And I couldn't talk about analytics without talking about privacy. And quick disclaimer, I don't have a legal background, so just take my opinion on this. And this is what I've been finding during this process. So to give you a quick context about this, let's start with cookies. So not all of those analytics tools use cookies, but a lot of them do. So if those tools use cookies like Segment, if user hasn't accepted the cookies, you can track them. And we lose about 30% of data because of this. So be aware that you need to follow cookies compliance on this. And then you have a lot of regulations. Most of them are different according to the countries your product is at. So always be mindful of regulations like GDPR for Europe or CCPA for California. And most of them are concerning data privacy. And they, for example, you need to give the users the option to explicitly accept or deny cookies. And again, always take into consideration the regulations that apply in the countries your product is. And then personal identifiable information. Play on the safe side here, and probably don't need to log their address or their credit card number. So keep it as essential as you can. And users always need to know if you're logging personal data. So you need to let them know through your terms of services or privacy notice. So take this into consideration. And again, always try to reach out to someone from legal to help you finding the right solution for your product, the countries you're in, and everything, because these are very sensitive matters and no one wants to get in trouble because of this. And it doesn't matter if you have all the data in the world if you do nothing with it. So to read the data, you have two options. You can use the tools themselves. So for example, we use the data from Segment goes to Mixpanel, and we use Mixpanel to analyze and to build our reports. Or you can use an external warehouse. So let me start by tools. As I was saying, we use Mixpanel. This is a screenshot from Mixpanel. And you can see here that we are only adding the events we want to track. So this is the name ID that I was talking before. You can add some conversion criteria, some filters. For example, we always filter for employee emails. So we know that our data is not biased by internal interactions and operations. You can define your range, and you can build a lot of charts. You can have funnels like this one that was measuring the drop-off rate in a form. You can have pie charts, wherever you feel like fits better your use case. And then always try to keep a change log or some kind of log of the changes. Mixpanel allows you to add annotations. So basically, you can leave a comment with the time that a change happened. And this is really useful when you're analyzing data. And if you see any change, you can see if it's correlated to a change in the product. And now I'm talking about external warehouses. Most products allow you to connect with external databases or data sources. Single store is not a supported segment data storage yet, but we use it anyway as with some internal code that copy the events to our own single store database. And then we just consume the data as a regular database. For example, we can use our feature notebooks to create some charts as well. And basically, we allow the team to either use Mixpanel or our single store database itself. This database has a lot more data, so we can correlate with other things. But basically, you can use whatever suits you and the team best. So I want to leave you with this quote, which says that most decisions should be made with somewhere around 70% of information, because if you wait for 90%, probably are being late. And if you're working in an early stage product or a startup, you know that you need to ship fast, to learn fast, and iterate, and don't feel like you need to have all the data in the world and the flows all covered, but try to find a balance between what works for your team, for the engineering team, and the data you need to make some backed up decisions. So those are the 10 things I wish I had known when I started working on front-end user tracking. And thank you so much for your attention. Feel free to reach out to me.
About a short story about how to customizable login experience.
Yes.
You go ahead.
Great, great. So Hello, everyone. I'm so happy that you are here together with me to basically finish the little conference. And I was a little nervous because this will be a really short talk, a lightning talk. But I still hope that I can basically bring you to a little journey which I had myself when it comes to a seemingly complicated topic. So let's take a look. Because my talk is called "You Shall Not Pass." Well, how many people are recognizing this quote? Oh, I love you already. Because sometimes I'm a little, I don't want to sound so negative, but it's one of my favorite movies, and I'm always a little sad if someone doesn't know it. It's like, you come to me, we'll do a little like cinema evening. You can rent cinemas sometimes, so it's not that expensive. And yeah, you could call it detention. I don't want to call it like that. It sounds too negative, but yeah, if you didn't watch Lord of the Rings, please try to catch up. It's from the first movie where Gandalf, a wizard, is basically blocking the entry of the Balrog, which is a really scary monster who would love to have all the companionship basically somewhere, I don't know. But like he's blocking the entry, saying you're not shall not pass, and basically that's it. But I guess I'm already onto spoiler territory, so yeah, I just love this movie. I'm sorry. Before that, real quick, my name is Ramona. Actually, it's wonderful to be the speaker after Marta because it's my second name. So this is wonderful. I'm working as a developer advocate at Auth0. And apart from that, I'm a Cyprus ambassador. I'm pretty passionate about testing. So if there are any people who were at my workshop, thank you so much. It was about testing. And yeah, it's a lightning talk. So it's about a neat little discovery, which is a little connected to this quote, "You shall not pass." Because there are other ways where you are not allowed to have entry, right? Especially when it comes to queues in front of a club or in front of some kind of event where many people will be in. And I don't know if you already have been inside of one of those queues. You don't need to go to Berlin for that. I guess it's many places where you could do that or where you need to wait. But this it's not from our point of view. It's from the point of view of a bouncer. So the people who say like, you are not allowed to go in or try next time. So in this case, it's about the persuadable bouncer. So a bouncer which you might be able to persuade to let you in. But well, you might ask yourself, you might wonder, what does that have to do with web development? Well, if you are blocked entry, it's a perfect allegory on authentication. And we were talking about a persuadable bouncer, right? Someone you could maybe persuade. So I would like to take you through a journey which is basically on custom authentication, because you might have some requirements, some obligations you need to take into account. And sometimes this is difficult to implement or even almost impossible without having redirects. So how can we get the bouncer to open the door, or how can we teach him when to open the door? So it's the point of view of the bouncer. And this makes the requirements to grant access to like the guest or the Balrog or whoever you want to have coming in, or rather not, becoming your use cases. So the first use case could be, from which country are you? And it doesn't need to be that strict like sanctions. It could be like you are on UK, for example, and it might be a little more expensive to ship goods to other places because you need to cover, I don't know, water or oceans or seas. There might be plenty of reasons why you need to know from where a person is coming from. Well, you could use lots of kinds of ways of whitelisting countries or blacklisting countries the way you want to. For now, I would use a little screenshot of an Auth0 action to showcase that, because it has a neat little site which fits wonderful into a slide, and I cannot get into depth right now because of the short time frame. But actually, you should think about whitelisting those countries in your database, in your backend, in Auth0, or wherever you want to do it. Okay, one way to let the bouncer know that it's okay to let some people in, depending on the country, or not. Okay, next one. Are you a robot? Well, it sounds a little weird because we know that these people here are humans, right? We're not a Blade Runner right now, I think. Well, in the internet, it is not that obvious, obviously. Well, we try to find out if you are real, if you are human or not. And I guess every one of you already got those little, let's call them riddles, where you need to find motorbikes or cars or whatever, like all those captures. You can basically integrate them pretty easily by using the Google integrations. I have one here for Vue, but there are plenty of those, so it's not that difficult to find those if you use Google as a search engine or whatever. But it doesn't need to be only those to basically see if a person is real or not, because there might be the manual way, which is a little boring, because I guess many people of you already saw it or basically stumbled upon it, using some input fields a normal human user would not be able to fill out because it's hidden or whatever, but a bot doesn't know about that. Or some more creative ways, so little games, little riddles which are actually funny. So you could take a look at the Copilot. If I would have a little more time, we would dive into that one, because you could play tic-tac-toe. You could basically ask, what is love? And I guess all people who don't say, baby, don't hurt me, are not human anymore. So there are a couple of ways on how to do it in a not that annoying way, right? So yeah, try to appeal to the human in the people, or all those like little references a bot might not be able to catch. Of course, at some point they could, but it's a little more difficult, right? Okay, next one. Well, do you accept the new terms of service? Sometimes those will be changed, and in most cases they're not always changed for the worse, like Adobe happened this time. But well, if you need to implement that into your authentication, in your application, you might face some challenges. For example, you have many redirects from dependencies to third-party services. You have a break inside of your loops because you need to redirect. You need to leave your own application and have many steps in between. So sometimes it doesn't feel confident. And now I need to start with the obligatory product mention, because there's some little feature in Auth0 which I would like to showcase to you today, because it's in early access since May 7th, I think, at least for some tenants, for some countries, and they rolled up for other regions already. And it's available for Europe. I checked that. So Form Through Actions is a visual editor for customizable forms. And this includes authentication and login forms. So it's a low-code approach to extend your login processes to all the information you need. So maybe countries, maybe captures, maybe whatever things. But right now we will take a look at the custom terms or terms of service, new policies, whatever we want to. So let's take a look together. So we can open up a new form here. We'll start from scratch because I want to show it to you. And you have this editor here, so you can find lots of components and everything you might need. And when you think about new terms of services, you might need a dialog, which is having some kind of text in it, a link for it, and a way on getting the validation of the user. So let's take a look how I'm building it. Okay, it's not playing like, there we go. So we'll go for the which tags. We will enter some wonderful creative headline, of course. There we go. Afterwards, it's a little entry text on maybe summarizing the main points, maybe being more creative than me using lorem ipsum. Well, whatever you need. And then I will continue with the little radio button to get the approval of the user or not. I'm using a random link, but of course here would be your actual complete terms of service. Then we will add a flow to really know if the user is accepting or not. So we will validate it and making it a little more pretty so the flow is visually appealing for others to maintain it later on, for example. Yes, sometimes it's a little icky, but well, early access is early access, right? So if you have some opinion on this first impression, please let me know. That would be great. And then we go there. This app metadata flow is leading to the validation, and it's the way on how to get to the Auth0 backend. And here we can see the body which we will be sending, basically. Okay, so when it comes to another question we want you having answers, like tell me more about you. This is basically showing us one way where those forms can be useful too. It's on progressive profiling, where you try to incrementally collecting additional information on your users, which is a prime example, for onboarding. If you want to know if it's a company, if it's a private customer, which might have different needs. Or like, again, the different countries, and you want to only access the data you need. So be compliant to the certain countries. Signaling a little bit from the prior talk to be really careful on that one. So if you want to do that, and you don't want to completely build it from scratch, you can basically use some custom templates. You can customize them, of course, but it's a wonderful starting point for those forms. So you can go there. It loads a little bit, and there you see some questions we will ask the user in onboarding them as soon as they are registered. Like, how are you planning to use our application? We will map those values they give to us, and depending on that one, we will basically change the question we will ask them. And afterwards, we again capture the answers, validate them, and resume the authentication flow. Well, those are pretty short things, I know, not in depth, unfortunately, on how to persuade a bouncer or actually train the bouncer on when to be persuadable or not. I hope I can make this talk a full one and not only a lightning talk to get more into code and more into depth, but maybe it gave you a first impression on how to cancel those challenges. Well, what else to say then? Thank you so much for your time. Thank you so much for ending the conference together with me. I will leave you to the beers. And one little thing, if you want to know which events I'm up next or some other security or identity related topic, not marketing related, I'd be happy if you want to join up to my newsletter. Thank you.